Hi, good evening, my dear future makers. I hope all of you done today's exam very well. And today we have a discussion about our paper analysis, question and answers. That too, this is on memory based. I hope all of you got that point. And today I am here myself, Vamsi Krishna. I am going to deal artificial intelligence in our ACE Engineering Academy. And now let me introduce our respected faculty team one by one. And he is our Ramesh sir. He is going to deal our database and data warehousing subject in our DA paper. And coming to the faculty, Srinivas sir, he is going to teach our subjects like data structures, algorithms, and also PL. He is going to teach today. And let me introduce Rajesh sir, aptitude faculty, and our mathematics faculties, Aditya sir and Venkatesh sir, and everyone. Without wasting the time, let us start the session.
Hello everyone, myself Ramesh Masuna. Welcome to ACE Engineering Academy and ACE Online. As today we are going to discuss about the data science and artificial intelligence memory based questions on GATE 2025. Let us start the session with the weightage analysis. As in engineering mathematics, there are many number of questions are asked. Like you see, 1 mark 12 questions and 2 marks 13 questions. It is 26 plus 2. 38 marks came from mathematics. So I think you can understand the power of mathematics in the case of data science and artificial intelligence. When it comes to the programming and data structures, there are totally 8 questions came, and which is of totally of 13 marks. And when it comes to the databases and data warehousing, there are totally 7 questions, which is almost same as GATE 2024 DA paper. In GATE 2024 DA also, DBMS, we got 11 marks. This time also we got the same 11 marks. This is 4 2 marks questions, 8 marks, and 3 1 mark questions, totally 11 marks. And in machine learning, there are 8 questions, 4 1 mark and 4 2 marks. That is 8 plus 2, 8 plus 4, 12 marks. In artificial intelligence, 3 1 mark and 4 2 marks, totally 11 marks from the artificial intelligence. And as usual, aptitude will have, general aptitude will have 5 1 mark and 5 2 marks, totally 15 marks from the aptitude. And when it comes to the number of numerical answer type questions and number of multiple choice and multiple selection questions, there are 12 numerical answer type questions, 35 MCQs and 18 MSQs. You have to observe every year the number of numerical answer type questions and multiple selection questions are increasing and multiple choice questions are decreasing to increase the quality of the paper. When we see the overall paper when compared with GATE 2024, as everyone of you know that GATE 2024 is easy paper. But this time GATE 2025 is not easy, it is moderate to difficult level paper. it is not that the person who prepared for computer science. And I have seen many of the students who prepared for the computer science, they also have written GATE DA paper, just like that. Definitely I can say the people who write DA paper just like that, not able to crack DA paper. Why? Because the DA paper this time is very worthy paper. So that it is an indication to the future aspirants, those who prepare for computer science and they wanted to write DA as well casually and try for it. It is not that if you prepare DA dedicatedly, then only you can able to crack the paper. Because the level of paper when you see computer science and DA paper is bit higher than the computer science. So future aspirants, prepare DA dedicatedly if you are thinking about GATE DA. This is the suggestions and these are the opinions from our expert faculty. Okay, let us start the session with the memory based questions. I am going to take the databases and data warehouse. In the databases and data warehouse, totally 3 1-mark questions and 4 2-mark questions, totally 7 questions consisting of 11 marks from the subject. Total 11 marks came from databases and data warehouse, which is same as GATE 2024. But definitely I can say the quality of questions when compared with GATE 2024 in database and data warehouse is very good in GATE 2025. Let us start with the first question. If a relational decomposition is not dependency preserving, which one of the following relational operators will be executed frequently to preserve the dependencies? To preserve the dependencies, which relational operators will be frequently executed? Let us say an example. If we have a relation R having attributes A, B, C, having the functional dependencies A, B to C and C to A, and this relation is the third normal form relation. Suppose we decompose this relation into smaller relations. Let us say R is decomposed into R1 of AC and R2 of BC. This decomposition makes the relations to be in BCNF. It is called a BCNF decomposition. So C to A dependency you can see in R1 relation, but AB to C dependency is last. Because AB to C dependency last, so this relation is not recommended to do decomposition up to BCNF if you are interested about the dependencies. Means this decomposition causes loss of dependencies. But how to get these dependencies, what we have to perform to show these dependencies, to preserve these dependencies? If we join these two relations, you are going to get a relation R ABC, which is going to definitely satisfy the dependency ABC. It is a meaning that suppose if dependencies are lost, repeatedly you perform a join to preserve the dependencies. Here the options are given: join, select, project, set union. What it is to be done repeatedly, we have to perform a join to preserve the dependencies. The answer for this question is option A. Coming to the second question. There it is given 3 relations. One relation is called car, model, serial number, color, make, maker, model, own, owner and serial number. It is clearly given the tuple in the car specifies the car models, it has some serial number and what is the color of the car, and make is going to have 2 attributes we call maker and model. The maker specifies the make, like just like a Honda or something else, and the model will specify the model of the car. And own will have 2 attributes, owner and serial number, which owner is owning which car. That information is there in the own table. Here it is given a relational algebra expression, and this relational algebra expression having join operations followed by some selections and projections. The question is to know what is the output of the query. Certain options are given. First, we'll understand what the query goes to return it. Look at from the make table, this table, it is going to find those records for which the maker is ABC. So it means it is going to find the records of maker and those maker name is ABC, right? Let us an example, if I have a make table having maker and model, and maker is ABC and some model 1, and maker is ABC, some model 2, and maker is XYZ, some model 3, something we have, because model is a primary key. So what this query is going to select, it is going to select the tuples of make, where maker is ABC, these records are going to be selected. And that result is going to be joined with which table? Car table. In the car table, we have a condition in the car table, join of the tuples with car. Here we can assume it as a natural join, because natural join, what is the common attribute between car and make? We have a model. Because model is a common attribute, join is going to be done based on the model, right? And model, serial number, and we have a color attribute. Say model M1 having a color red and serial number 1. Model M1 also have green color model and serial number 2, because serial number is a key, and model M2 is of red color and serial number 3, and there is a pink color of model 3 and serial number 4. We have like this. So what the second query will do, it is going to perform a join between the car and make based on the attribute model. Look at M1 has two matches. Look at this matches M1 equal to M1, M1 equal to M1, M2 equal to M1, sorry M2 equal to M2, and because it is not in the output of the first query, it doesn't have any match, these three records are selected. In that these three records, which records are going to be selected? It is going to select the cars of color red. This is a red color car, this is a red color car, these two are not selected. Then finally this is going to be joined with own. What is a own table? Own table will have attributes owner as well as serial number. Let us say this combination is together is a key, and owner A owns serial number 1 car, owner number A, owner A also owns serial number 2 car, owner B owns serial number 3 car, owner C owns serial number 4 car. Such kind of data is there. Now what it is doing, it is joining the two tables with respect to serial number now. Now these are the matching, right? This one is matched with this 2 anyhow it is not selected, and this 3 had a match with this. And these are not having any matches, means which owners are selected? A and B. Now just observe who are A and B. A and B are the owners who owns the vehicles of serial number 1 and 3. Serial number 1 and 3 are the vehicles of red color, and these red color vehicles are manufactured by which maker? The maker ABC. Means the output of this query is to display the owners, who own red color cars, made by which maker? ABC maker. Made by ABC maker. Because all the options are not readily available, because based on this query, that query is going to suitable for which expression, means which English like expression that we have discussed. So means what is the output of the query? It is going to display all the owners who own red color cars made by maker ABC. This is one question. And there is another question, this is also 1 mark question. The another question is on SQL nested queries. It is given a loan table having certain loan numbers, branch and amount. Here the question is the number of tuples returned by the following query. Now what query is given? Because it is a nested query, first innermost query is going to be executed. Select max of L2 dot amount from loan L2 where L2 dot branch equal to SR Nagar. L2 dot branch equal to SR Nagar means it is going to select SR Nagar branches from the loan table. SR Nagar branches are these 3 and these are the loan amounts in the SR Nagar branch. In that it is going to find the maximum amount. Now what is the maximum amount? 65,000 is the maximum amount. Its outer query is going to be executed next. The outer query says select L1 dot loan number from loan L1 where L1 amount is greater than 65,000. Now which tuples having greater than 65,000? Incorrect, incorrect, incorrect. This is correct. 70,000 is greater than 65,000, 80,000 is greater than 65,000, 90,000 is greater than 65,000, but 50,000 is not greater than 65,000. So that how many tuples are going to be selected? 3 tuples are going to be selected. Answer for this question is 3. The next question, it is a little confusing type of question to the students, but if you have a clarity you can answer it, but still we have to wait for the answer, official answer from the IITs. What is a question? You look at, there is a table given, table definitions are given. The one table definition is person with Aadhaar char of 12 means Aadhaar number is of 12 characters and which is a primary key. Okay, happy? And name which is of 32 characters. There is another table given customer and because definition is mentioned name varchar 2 of 32 means name is a 32 character string. Email is varchar 2 of 30 and which is a primary key. And phone is char of 10 and no conditions are mentioned on the phone. Aadhaar is char of 12 characters for Aadhaar. And it is mentioned foreign key of Aadhaar means this Aadhaar is a foreign key that references to the person table with Aadhaar. This is referencing to the person table with Aadhaar. So it is primary key, foreign key is referring to the primary key, no doubt in this. The question is which of the following is are true? It is a MSQ type of question, multiple selection type of question. Which of the following is are true? Phone can allow null values. Do have any condition on phone? No condition. Now phone is allowed to have a null values. It is true. And option B given, Aadhaar is candidate key in customer. In the customer table, Aadhaar is candidate key. But here Aadhaar is declared as a foreign key, but in general terms, if I have to talk about it, Aadhaar number is unique for every person. Means no 2 persons has the same Aadhaar number. So Aadhaar can be a candidate key in the customer table, right? This is also correct option. Aadhaar is candidate key in person. In person table, Aadhaar is a primary key and primary key can definitely be one of the candidate key. So that option C is also correct. Aadhaar can allow null values in person. In person, what is Aadhaar? Aadhaar is a primary key. Can primary key allow null values? No. Because primary key will not allow null values, then answer for this question, sorry, option is wrong. So answer for this question is A, B, C are correct answers, right? And this is, Aadhaar is a candidate key in customer, it is based on the assumptions. As in the real world, we understood that no 2 persons has the same Aadhaar, Aadhaar does not have a duplicate, so we can assume that it is a candidate key, but no such data is mentioned in there. But this is also based on the assumptions, we can say it is a candidate key. Fine? Right. And the next question is based on the keys. This kind of questions we have solved many, but again this is MSQ type of question. What is given? Consider there is a relation R of A, B, C, D, E, F, G. These are the 7 attributes with the following functional dependencies. The dependencies are A to B, C, E, F, B, C to A, E to D, G. which of the following is correct? Here only A is a candidate key. Check whether A is a candidate key or not. How I can check? By taking the closure of A. What is A closure? A, B, C, E, F. With B, C, A. With E, we are going to get D and G, all attributes. Then A is candidate key of the relation. It is also mentioned BC is a candidate key. Take the closure of BC. B, C, A. With A, we will get E, F. With E, we will get D, G. So we are getting all attributes using BC closure. So BC is also key. And it is also mentioned E is also candidate key. Just take the closure of E. E closure is E, D, G. So E closure not containing all the attributes. So it is not a candidate key. So what is a candidate key? Both A and BC are the candidate keys. So only A is wrong. Both A and BC are candidate keys, right? And A, BC, E are candidate key. E is not candidate key. It is wrong. R is not in BCNF. Now you tell me when a relation is to be in BCNF. A relation is to be in BCNF if every LHS of the functional dependency is a super key. Look, is A is a super key? Yes, because A is a candidate key, it is also called super key. Is BC is a super key? Yes. Is E is a super key? Not super key. Because it is not super key, because left hand side of a dependency is not super key, it is not in BCNF. So it is mentioned not in BCNF, it is also correct. So answer is both B and D. Look at this question. This question asked on division operator. It is given two tables. Consider the following tables. The one table is borrower, having customer name and loan number. These are the records. And another table is loan, having loan number, branch and amount. The question is number of tuples returned by the following queries. How many tuples? It is question is based on the division operation. Loan is joined with borrower. Loan is joined with borrower. We call it is a natural join. How this loan and borrower is to be joined based on the loan number, which is common. Now look at the common things like mappings. L1 equal to L1, right? And L1 equal to L1. L2 had a match. L3 had a match. L4 also had a match. L5 had a match. L6 also had a match. L7 had a match. And L3 had two matches. Now look at how many matches we have. Totally 9 matches we have. And in these 9 matches, it is finding the customer name and branch. Customer name and branch. So here I will be writing the customer name and branch that has a matches. The customer name Karthik. This Karthik had a match with branch SR Nagar. And again Karthik had a match, Karthik K. Look at this had a match with which branch? Banjara Hills. And again Karthik is a customer. He had a match with Kondapur. And in the fourth tuple, again we have a Karthik. And it is L6. L6 had a match with Balanagar. Karthik had a match with Balanagar. And look at for Ankit. Ankit is L1. L1 is matching with SR Nagar. Ankit matching with SR Nagar. And look at Balaji. L2 had a match with SR Nagar. And Smriti L3 had a match with SR Nagar. And again we have a Smriti, and she is matching with SR Nagar. So Smriti L3, I think this is duplicated. I think it should be L6. Maybe it could be L6. Suppose if it is L6, Smriti is matching with L6, then it could be a Balanagar. And Divya matching with L7, Kondapur. This is Kondapur. Now this is a result of join, right? This is a result of join. Now what is the second query? Second query is selecting the branch from loan table. Branch from loan table. Look at what are the branches we have? SR Nagar, Banjara Hills, Kondapur, Balanagar, right? So we have a branch, it is to be selected, and the branches are SR Nagar, Banjara Hills, Kondapur and Balanagar. And this is having customer name and the branches is the result of the first query, and that is the result of second query. Between them we have a division operator. Now you observe what division operator will give you when customer name branch division with branch. Customer name branch division with branch will give you customer name that had a match with all branches. Now see, these are the customer Karthik. The Karthik had a match with SR Nagar, Banjara Hills, Kondapur and Balanagar. So that Karthik is in the output. And A Ankit had a match only with SR Nagar, means Ankit does not have match with all branches in the branch table. So Ankit won't come in the output. And B Balaji also had a match only with SR Nagar, not with all tuples. So it is not in the output. And Shruti had a match with SR Nagar and Balanagar, but not with Banjara Hills and Kondapur. So Shruti also will not come. And Divya matching only with Kondapur, but not with all. So Divya also not in the output. So who is in the output? Karthik is in the output. So means how many rows are returned in the output? One row is returned in the output. So answer for this question is 1. 1 is the answer for the question. Right? And one question came in data cube on data warehousing. Last year in 2024, from data warehousing only one question asked on data normalization, that to Z-score normalization. That is a 1 mark question. This time, as I was keep on telling to my students that this time you can expect a question on OLAP cube. Same thing happened this time. A question came on OLAP cube and OLAP operations. But it is something different. It is not regular type of question. So what is given in the OLAP operations, fact table is of the form fact D1, D2 values. We have a fact table. We have a fact table had D1, D2 and value. It is mentioned D1 and D2 are the dimensions and value is the dependent value for the dimensions. It is mentioned D1 has 3 values and D2 has 2 values, then the number of tuples returned by the following queries. Now what is a query? Select dimension 1, dimension 2, 2 dimensions are selecting, and it is finding sum of values from the fact table grouped by cube of, this is slightly different, cube of D1, D2. So we have discussed about OLAP data cubes. In the OLAP data cubes, D1 dimension has 3 values, D2 dimension has 2 values. It is directly straightforward a formula. The number of tuples in the output of this query is the 3 values in the dimension 1 plus 1 null value and 2 values in dimension 2 plus 1 null value is possible, and the total number of tuples possible is 3 plus 1 into 2 plus 1. 3 plus 1 is 4 into 3, that is equals to 12. So how many tuples are going to be returned? It is going to return 12 tuples. Here one option is missing, this is 12. Here the number of tuples returned by this query is 12 tuples. These are the 7 questions came from databases and data warehouse. By looking these 7 questions, definitely I can say the person who is preparing databases and data warehouse perfectly can able to answer the question. And except the candidate key kind of question, remaining all questions, I feel it should be somewhat you can think for a moment and answer it. It is not that directly you can answer it. This time, as I was keep on telling, this time paper is going to be tough as usual. Paper is above moderate to the difficult. And those who are prepared very well, they can able to success. Hope for the better results. Thank you.
Hi everyone. From the general aptitude, we are getting the almost 5 questions. One of the question is data interpretation and mensuration, simplification and reasoning concepts. Okay, but based on the memory, 1 or 2 questions we are getting. Okay, so if a real number variables x satisfies 3 power x square is equal to 27 into 9 power x. Then what is the value of this one? Okay, what is the value of this one? Just observe, my dear friends, here. So 3 power x square. 27 means 3 cube. This is 3 square, that is 2x. So base is equal 3 power 3 plus 2x. 3 power x square. Okay, so base is equal x square is equal to 3 plus 2x. From this equation, you can simplify 2 power x square, okay, upon 2 power 2x. So 2 to same, 2 power x square minus 2x. So x square from this value, from this part, 2 power 3 plus 2x minus 2x, 2x cancel. 2 cube is the answer. Okay friends, one more question. And next one more. From the English, courage, bravery, earning, okay, according to the synonym, it is value. What is the name? Synonym, longing. Okay, my dear friends, the remaining those questions from the data interpretation and mensuration, okay, according to that points, memory based students sending the only these two only, friends. Okay, thank you.
Hello students, so now I'm going to solve the questions which were asked in engineering mathematics. So we have received nearly 25 questions. So if you look at the actual paper, there will be more than 25 questions. This will account to more than 40 marks. Compared to the last year, this year the questions were difficult. So let's solve this. This is an easy question. F of x is given. They're asking the 10th derivative. First, find the first derivative. Observe the pattern. E power x minus e power. So minus of minus will be plus by 2. Observe the second derivative, which will be e power x minus e power minus x by 2. So same way, if you look at this, the 10th derivative will look like this. Even derivatives, right? So the 10th derivative will be like e power x minus e power minus x by 2. Now they want the 10th derivative value at 0. So 1 minus 1 by 2, which is 0. The next question. Now this is a very silly problem. We usually teach this in the class. Go for the rationalization. So t square plus t minus t into t square plus t and then you have to multiply and divide. So you all know this pattern. So this is like t square plus t plus t. Like the numerator is like a plus b into a minus b, which is a square minus b square. The square and the root cancels. So you are left with t square plus t minus t square divided by a root of t square plus t plus t. So this and this cancels, you can take t common. When t square comes out, if you substitute these limits, you will get the answer as 0.5. So I want you people to reply. So how was the paper? Like you took the classroom, you attended the classes, so you have to respond. Were the questions were from the classroom or not? You keep replying. How was the question paper according to you? Tell me the difficult level. Now this is also a very simple problem. You would have solved many problems. B1 contains 2 black balls and 1 white ball. B2 contains 1 black and 2 white. B3 contains 3 black and 3 white. The probability of selecting the boxes B1, B2, B3 are 1 by 2, 1 by 6, 1 by 3. Now it's already given, if the ball drawn is white, then the probability that it was drawn from B2. So it's already given that the ball drawn is white, okay. So you can write it in short like this. It's already given that the ball drawn is white. What's the probability that it came from B2? If you can find what's the probability that the ball drawn is white, you will get the answer. So the ball drawn can be from B1, B2, B3. So I have to pick B1. The probability of picking B1 is 1 by 2. And from that I need a white. So 1 white among the 3. So it is 1 by 3. So it can be from B2. The probability of picking B2 is 1 by 6. And I want white from B2. So 2 among 3, that is 2 by 3. Plus the probability of picking B3 is 1 by 3. Now go through B3. So 3 black and 3 white. So it's 3 by 6. And then this is the probability that the ball drawn is white. So with this, what's the probability that it came from B2? Simply put this term here. That's how you have to solve in the exam. So it's a simplification now. So let me put 3 here to make the denominator same. So it is 2 divided by 3 plus 2 plus 3. So it is 2 by 8, which is 1 by 4, 0.25 is the answer. This was a silly question, not a difficult at all. Let's look at the next question. Keep replying. I'll be reading your chat. So I collected nearly 20 questions. I'll quickly show you how to solve them. So what's given here? X is az plus b, where z is a standard normal random variable. The expected value of x is 1. You all know, I've been repeating this in the class. If someone gives you like this is nothing but the variance of x. Variance of x is given. They want the values of a and b. So apply expectation of x is a into expected value of z plus the expected value of b is constant. Expected value of x is 1, a into standard normal random variable mean is 0, so it's b. So we got the value of b as 1. The variance is also given, so you should be good with variance of x. If someone says there is a random variable called az plus b, what's the variance of that? It would be a square into variance of z plus 0. And this is given as 4. It's a standard normal random variable. Z is a standard normal random variable. Variance is 1. So we have a square equal to 1. The value of a is plus or minus 2. Now based on the options, it was a MCQ. The value of a is 2. The value of b is 1. So let's proceed. Like wide variety of questions we could see in this paper. So what they say here is x is exponential random variable with parameter lambda. They gave the probability of x greater than or equal to 2 equal to 0.25. They're asking what is lambda. I have been repeating in the class, if at all a question comes in exponential, they'll use this. So we all know for an exponential random variable, the probability of x greater than or equal to k is simply e power minus k lambda. So what they gave, the probability of x greater than or equal to 2, so this has to be e power minus 2 lambda, and this is given as 0.25. Extract lambda. So apply log. So minus 2 lambda will be ln 0.25. 0.25 is 1 by 4. ln 1 by 4 is like minus log 4. This is minus 2 lambda equal to minus ln 4. So this is 2 lambda equal to ln 4. 4 is 2 square, 2 cancel. The value of lambda is ln 2. ln 2 was given in the options. So let's go to the next problem. So it was very difficult for the students to collect all this information. So with lot of efforts we have collected this. So we are trying to present in front of you. So this was from the linear algebra. there's a matrix A, and if you look at the matrix, a sum of elements in a row, you take any row, you add up all the elements of that, it gives you 1, it seems. And they created another matrix called B, which is B cube minus 2A square plus A, then which of the following is true? So now, if sum of the elements in each row of A is 1, so now how do we solve this? Can we find one of the eigenvalue? So what I have, like when I saw this question, what I thought was, why don't I take 1 0 0 1 as the matrix for verification? You see this, sum of all the elements in a row is 1. So 1 is the eigenvalue here. Then what could be the eigenvalue of B? B would be like, the eigenvalue of B would be 1 cube minus 2 into 1 square plus 1. So this and cancels. So the one of the eigenvalue of B is 0. If one of the eigenvalue of B is 0, then the determinant of this is 0. If determinant is 0, Bx equal to 0 will have infinitely many solutions. So this is the right answer for the question. So let's go to the next one. This is a very basic question. So what are they asking here? Which of the following are correct? It's a MSQ, linearly independent vectors are orthogonal. So linearly independent vectors need not be orthogonal, but orthogonal vectors have to be linearly independent. So it's a MSQ. This is correct. R power n has unique orthonormal basis vector. See, R power n can have a various orthonormal basis vector. So this is false. So R power n has not unique orthonormal basis vector would be the right. So I don't agree with R power n having unique orthonormal vectors. It can have different orthonormal vectors. So let's proceed. And please students, this is memory based question. Please understand, it's a memory based question. So once we receive the exact paper, we will try to put the solutions in front of you. We will have a discussion again. Now this was little tricky. Like I did not get any idea like when I saw this question. I tried many functions, but finally I got one function for the verification. When I take f of x equal to a constant, f of x equal to a constant, that was satisfying the given condition. If you say f of x is constant, then f of y is also constant. Then what is asked is, what is f of 1 minus f of 0? F of 1 is a constant, f of 0 is also the same constant, then the answer was 0. Now this was little tricky. I did not get much ideas while I was solving this question. So please respond, what was your approach while solving this? So there are many questions, let's take them one by one. We are not in a hurry. I want you people to reply as well. So now, do you people remember this? I have been saying that if z is standard normal, y equal to z square will be a chi-square random variable. So what's a variance for a chi-square random variable? The variance of a chi-square random variable is 2n, where n indicates the degrees of freedom. Here we have only one z square, like it is not like u1 plus u2 and so on. It is only one single random variable. So the variance has to be 2 into 1, which is 2. So this is the answer for the question. This was a very simple problem. Those who have attended the classes, for them it's like the direct question. So let's see. Now this was really amazing question. The way they created, this is also a MSQ. Right now I don't have the options. I'll show you how to solve this. X is a random variable with CDF. Usually PDF would be given, but here CDF is given. Cumulative distribution function is given. Now what I do is, the median of X is 3. So the median is given, what's the value of t, and various options were given. It was MCQ. So right now I don't have the options. So how do you find this? You all recollect, how do you find the median? The probability of x less than or equal to small x, you have to equate to 0.5. So, or the probability of x greater than small x, this also has to be 0.5. So find that observation. But the PDF is not given, CDF is given. Now this is nothing but the definition of CDF. Come on, x less than or equal to small x is nothing but the CDF. So what you do is equate this to 0.5 and extract the value of t. So various options were given. One of the option was t equal to 2. So now what I'm trying to tell is x minus t by 4 minus t has to be equated to 0.5. Sir, why it has to be equated to 0.5? It's a definition of median. For finding the median, the probability of x less than or equal to small x has to be equated to 0.5. And in one of the options, the value of t was 2, I think. So if I put this, t as 2 and I equate this to this, I have to get the value of x as 3. Now why I have to get the value of x as 3 is because the median of x is 3. So this is x minus 2, 2 into 0.5 is 1, the value of x is 3, this matches. So whichever value gives you the cumulative distribution function as 0.5, that particular observation x would be the median. So yes, this all matches. Here you need to put the value of t. The value of t is 2. How did I get that 2? It's an MCQ question, various other options were given, like t was 0, t was 2, t was 4 and so on. So this is how you solve it. Let's see the few more questions. Now this is also one of the fantastic problems. This time we got to see plenty of new patterns. Lot of MSQs were given, very difficult ones. Here again CDF is given, they are asking what's the probability of this event. I would like to find the probability density function. For that you have to differentiate this. 0, the derivative is 1 plus x by 2 and then 0. I'm trying to find the derivative because that's how the CDF and the PDF are related. They want the probability of this event. So x square less than or equal to 0.25 means it is minus 0.5 less than or equal to x less than or equal to 0.5. So this is what you have to find. So for that you have to integrate minus 0.5 to 0.5. In that interval it is 1 plus x by 2. So the integration of this is 1 plus x whole square by 2. The limits are minus 0.5 to 0.5. When I put the upper limit it is 1.5 whole square. When I put the lower limit it is 0.5 whole square. So 1.5 whole square minus 0.5 whole square, a square minus b square. A plus b is 2, a minus b, how much is a minus b? So 1 minus 0.5, 0.5. So okay, I got confused, so let me substitute the limits. It is 1.5 whole square minus, when I put this lower limit it is 0.5 whole square. So 1.5 plus this is 2 into 1 whole divided by 2, so the answer is 1. So are we doing correctly or did I miss anything? So 1 plus x whole square by 2, there is another 2 here because of the integration. So here you will get by 2, so the final answer is 0.5. I'm just solving the way a student solves in the exam, so please don't mind with this calculations. This is how you are supposed to solve in the exam as well. This is also a fantastic problem. He says there are 100 fair dice, A is an event that at least one of the dice shows 1 and he wants what's the probability of A. So complement rule, come on, it's a complement rule. If you want at least one die, then P of A would be 1 minus, no die shows 1. So P of A is like 1 minus, no die shows 1. So 100 dice, so it's like 5 by 6 whole power. All the dice should not show 1. So it's 5 by 6 whole power 100. This option was given. This was a very simple problem on complement rule. This was problem related to maxima and minima. This function was given to us and it was a MSQ problem. So what was the problem? I'll just tell you. What's the maximum value? The maximum value is 133 by 2. F dash, so I'll just show you. It's a closed interval problem, students. It's a closed interval problem. So you need to find the first derivative. You have to equate that to 0. You'll get some stationary points. Not only at the stationary points, at the end points also you have to find. Now I have done the simplification. I found that f of 0 is 133 by 2, which is 66.5. This happens to be the maximum value. So one of the correct answer was this. And the remaining two options were related to the stationary points that were wrong. And I found one more interesting option. The interesting option was they asked about the minimum value or the maximum value of the f dash. So what is f dash here? F dash is x square plus 7x plus 10. So what is the stationary point? So you have to treat this as g of x because the question was about the minimum value of the first derivative. So if I find the derivative of this, which is g dash, which is like 2x plus 7, the stationary point of the first derivative would be minus 7 by 2. If you find the second derivative of this, which is 2, which is greater than 0, this indicates a minimum. So that was correct. There are two correct answers for this. Hope you people would have solved this. This is a very simple problem on maxima and minima. Now this was really a fantastic problem. Like I can tell you, more than 95% of the students could not get this. Many things were linked. He says x is exponential random variable. He gives you the mean. So when he says mean is 1 by log 10, then I can find that lambda is ln 10. He creates a new random variable called y, which is the step function. So whatever he indicates, that's a step function. So how is the step function defined? It's the largest integer that is less than or equal to x. So it was this, and then the probability of y equal to L is q power L into 1 minus q, where L is a positive integer, it seems. What's the value of q? It took a lot of time for me to understand the question. Now you see the solution. What we do is, x is exponential, so x takes values greater than or equal to 0. So this is 0, this is 1, this is 2, this is 3, and so on. These are the possible values of x. What could be the possible values of y? If x is from 0 to 1, y is 0, because step of x is 0. If x is from 1 to 2, then step of x is 1. So the possible values of y are like this. Y takes value 0, 1, 2, 3, and so on. When you add up all the probabilities, you will get the answer as 1. But see this, he says that the probability of this event is so and so whenever L is a positive integer. So you need to find what is probability of y equal to 0. How do you extract this? I have an excellent idea of extracting this. So when will y take 0? So if you want to find the probability of y equal to 0, then this is same as the probability of x less than or 0 less than or equal to x less than 1. To find this, we have to integrate from 0 to 1 lambda e power minus lambda x dx. So integrating this will give you e power by minus lambda, lambda cancels. When you substitute the limits, it's like e power minus lambda minus 1 by minus 1, which is 1 minus e power minus lambda. And also the lambda value is given. Lambda is ln 10. So this will be like 1 minus e power minus ln 10. Array, what is minus ln 10? ln 1 by 10, which is 0.1. 1 minus 0.1 is 0.9. The game is not yet over. This is only partially solved. Now the probability of y equal to 0 plus probability of y equal to 1 plus so on, if you add, you must get 1. Now this particular probability, just now we calculated, how much was that? How much was that? It was 0.9, so take that 0.9 here, plus the probability of y equal to 1 is q power 1 into 1 minus q. The probability of y equal to 2 was q square into 1 minus q plus q cube into 1 minus q, and then so on. And this has to be equal to 1. So let's see how much is this. This is clearly in geometric progression. So if I take this q common, what is left is 1 minus q. No, 1 minus q should be common. 1 minus q is taken out, then it is like q plus then q square plus q cube plus so on equal to 1 minus 0.9 is 0.1. This is sum of infinite terms in geometric progression. A is q, common ratio is also q, so this is like 1 minus q into a by 1 minus r. This and this cancels. Beautifully, the value of q is obtained, which is 0.1. I really loved this problem. Wow, this is also an amazing problem. Students would have worried about this, but this is from central limit theorem. I have solved this model in the class. I want students to reply whether you have solved this or not. So it's like a lot of description was given. So this is not the complete question. Xi is a Bernoulli random variable. So all Xi's are IID Bernoulli random variables. What would be the mean? So what's the mean of Xi? Mean of Xi is 1 into theta plus 0 into 1 minus theta, which is anyway theta, and theta value is given as 0.25. They created a new random variable called y, which is summation I from 1 to 300 xi. What is mean of y? Mean of y, so you have to add all the means. So it's like 300 into theta, so 300 into 0.25. How much is 300 by 4? So 7, and then 2 here, so 5. 75 is the mean of y. What's the variance? You all need to know what is variance. So the variance will be sum of all the variances. So it is 300 into what is variance of xi. Variance of a Bernoulli random variable is np into 1 minus p, where n value is 1. So this is something like theta into 1 minus theta, which is 0.25 into 0.75. You can substitute that here. It is 0.25 into 0.75. So now this is 1 by 4, this is 3 by 4, abba. So this will be like 300. I need a virtual calculator. 1 by 4, 3 by 4. So this is already 75. 75 into 3. 25 into 3 into 3. So it's 25 into 9. 5 into 3 is 15. 15 by 2 is the variance, which is 7.5. Am I right? So this is variance. This is variance. Actually, I took the square root. This is 25 into 9 by 4. I need sigma y. I'll tell you why I need sigma y. 5 into 3, 15 by 2, which is 7.5. Why I need that is, if they're asking you to find the probability of this event, convert that problem to standard normal. You all know central limit theorem, right? So let's convert that to standard normal. So let's see what happens. So how do you convert? 60 less than or equal to y less than or equal to 90, convert karo. So this is like 60 minus 75 by sigma y less than or equal to y minus 75 by sigma y less than or equal to 90 minus 75 by sigma y. This quantity is z. Sigma y is how much? 7.5. This is minus 15. Minus 15 by 7.5 is minus 2. This is 2. So now we have something like the probability of 2 less than or equal to z less than or equal to 2. This is minus 2, by the way. In the options, so they gave a function like this, phi of x, which is 1 by root 2 pi integral minus infinity to x e power minus x e power minus z square by 2. So z square by 2 dz. So the answer has to be something like phi of 2 minus phi of minus 2. So you could recollect this. Let's go to the next problem. Now this is another fantastic problem. We couldn't get all the options. Something like we got information that this xi, let me put this, solve it for you. So like xi takes only two values, students. Xi takes 0 and 1. Let's say the probability that xi equal to 0 is, let's say, 1 minus p. The probability that xi equal to 1 is p. Let's say this information is given. This is like usually Bernoulli random variable case. So they are adding all such random variables and then dividing by n. So how do you find the expected value? First of all, find what is expected value of xi. It is 0 into 1 minus p plus 1 into p, which gives you p. Now I want the expected value of p hat. So it is 1 by n, and they are all independent, so you have to add the individual means. If I add the individual means, it's like p plus so on p. So np by p is p. Yes, I have to agree that the expected value of p hat is p. So what next? The variance of p decreases, n increases. This is a MSQ. Lot of MSQ questions appeared in mathematics. So variance of p hat decreases as n increases. You need to find the variance then. So first of all, what is variance of xi? We know the mean. The mean is p. The variance of a Bernoulli random variable. So let me recollect about binomial random variable npq. So n is 1. So this is p into 1 minus p. So the variance of the single random variable is p into 1 minus p, but I need the variance of p hat. Now p hat has a summation, it has a 1 by n. You all know the properties. The variance of p hat, if you want, since 1 by n is there, you have 1 by n square coming up. They are all independent, there is no covariance involved. So it will be like 1 by n square into sum of the individual variances. So it will be sum of individual variances. So it is n into p into 1 minus p. This n cancels. You have an expression called p into 1 minus p divided by n. As n increases, what's happening to p hat? It is decreasing. Yes, I have to agree with this. So these were the two right answers. We couldn't get the option D, but these were the right answers. So let's see, we have any other questions. Yeah, we have few more questions. Nearly 25 questions are there. We got nearly 20 questions. We have the other data as well, but they are all MSQ. Once the original question paper releases, we will bring it to your notice. A is in plus x into x transpose, and x transpose x is 1. Then which of the following is are correct? A is invertible, 0 is the eigenvalue of A, rank of A is n, and then A inverse has a negative eigenvalues. This was little tricky. So in the exam moment, if you have to solve, you can take some substitution, like you can verify it. So if you, let's say, let me take A is a 2 cross 2 matrix, I is a 2 cross 2 identity matrix. Let me take x as 1 0, So what is A? What is A? It will be 1 0 0 1 plus what will be x into x transpose? Will it be x into x transpose is like this, 1 into 1 is 1 0 0 0. So you are going to get 2 0 0 1. So it is invertible. Yes, it is invertible. 0 is eigenvalue of A? No. Rank of A is n? Yes. A inverse has a negative eigenvalue. Now, this needs to be properly solved. Okay. Now, what I feel is this is clearly a positive definite matrix. Okay. So, we need to get the exact question. Once we get the exact question, we will tell you the answer. But as of now, I feel this is a positive definite matrix whose eigenvalues are all positive. If all eigenvalues are positive, A inverse eigenvalues are also positive, this could not be the answer. These are the appropriate answers. So, right now we have these questions with us. Once we get all the questions, we will definitely come with authentic solutions in front of you. So, I wish good luck for the students who wrote this exam. So, the next subject will continue.
Hi students, I hope all of you done today's exam very well. My dear, from the information whatever we got from our students, on the memory base we are going to discussing these questions. My dear, first of all let me say one foremost important point that the weightage of AI is artificial intelligence in our data science paper, that is fixed actually. Last time whatever we got 7 questions from AI subject, and today also what we heard from the students is we got 7 questions. And let me add some important point here. My dear students, 3 weeks ago we have conducted pre-gate exam. In pre-gate exam we also conducted the YouTube live session, and all the questions whatever we discussed it is available now. If you compare the actual gate paper with our pre-gate paper, let me mention the point here. So, My dear, in pre-gate paper, I have given some 7 questions from our artificial intelligence paper. In pre-gate, what we did is, we have a question like, uninformed search. I think in uninformed search, I touched IDDFS. And we have a question from informed search. In the form of informed search, from this topic, I framed a question from A-star algorithm. And when you are taking logic, I have given a question from what do you call multiple quantifiers. And also some question like, some basic question we can say, something like tautology we have taken. And after that we have question from alpha beta pruning, and also I touched Bayesian networks, and also another some theory questions from probabilistic reasoning like. These are the questions I have given in our pre-gate exam. But if you observe our actual gate paper, my dear, from the students' information, what we understood is, we have a question from alpha beta pruning, and also A-star algorithm, and some basic question just like propositional logic. And after the propositional logic, and there is a question that refers to the search unit, and I can say that that is somewhat generalized questions. My dear, out of 7 questions, we got information proper, somewhat authentic information, we can reliable that. That is from 4 questions. Let me show the questions and let us discuss. I can understand you are somewhat eager. You want to know that either your answer is really correct or not. As a student, you have that fever. I can understand that, and let me discuss, but you should make a small note that all these questions, whatever I am discussing now, they are memory based, right? My dear, just to say this, there is a question like this. They given some directed graph, and in this graph there is a source node, and in each and every source node they given some estimated cost, yes, heuristic estimated cost, and also actual cost. What I am saying, I am talking about G of n value and H of n value. If you observe the source node, there is a source node here just like S, and there is a node here just like A. So the number 4 indicates this is actual cost, you can say, this is G of n value. And here within the parenthesis, they given 2. Yeah, the actual notation is within parenthesis, they can give the, what do you call, heuristic cost. But instead of that, in examination, what I heard from the students is, actually it is they given like H is equals to 2. So whatever it may be, the data is like this. So they asked that information in this way. Different options are available. If you use A star algorithm, my dear, if you go for A star algorithm, then what the option is going to be take? That means from the source node to reach the goal node, what the search process you are going to follow. Yeah. Here, the A star algorithm, the actual scenario, the actual parameter is, it's nothing but f of n value, my dear, f score. It completely depends on f score. And f score refers to, it's nothing but g of n and h of n. So you are at particularly some node like n. What is f of n indicates? That f of n indicates that it is just like a cost of the path from the source node to the goal node via node n. And whereas going to g of n, what is g of n? G of n is the actual cost, that is from the source node to the current node n, right? And after that we have h of n. H of n refers to, that is actually estimated cost from the present current node to the goal node, or what you can say, that is something like the heuristic value, h of n. So here it comes to f of n here, that is equals to g of n and h of n like this. Let me start with values. Let me take the node here. This is the node value. Let us suppose node n here and g of n, h of n and the corresponding f of n, let me say like this. Now you are at source node, initial node, let me start with node s. If I take node s here and the g of n, when you are starting with the g of n to the goal node, it's going to be estimated like anything. So it is the initial node, you can say. So g of n and h of n, we cannot say that, and no value is given for s also, right? And let me start with next node, that is like a. If I go with a, source to, that means s to a, we have 4 units cost. Let me take 4 units cost. And h of n value is 2 units, and it will become as 6 units here. And the neighboring nodes of s is a here, a I already taken. Let me start with e, and e comes to 1 plus 6. 1 plus 6, it's like 7. Now here you are at the situation like 6 and 7. 6 is going to be the minimum cost. So you are going to choose node A. And as a student, I hope in the examination parallelly you can observe the options, right? So what unlucky thing is, you can eliminate option D here. After S, E will not come. But we are with SA, SA, SA here. These three are the possible answer. Let me say in this way. Now after that, if you go for next node, the next node comes to be the possible node is, and it comes to 4 plus 2, 6, and 6 plus 2, it becomes 8. So if you take B here, 6 plus 2, that means 8. I already discussed this area. This story is over, my dear. Out of 7 and 8, the next minimum node cost is 7 units. So in that case, let me start with E. Okay. Then it will become yes, AE is going to be the path. So let me observe the options parallelly. Yes, AB, yes, AE here, yes, AE here. A cannot be the answer, D cannot be the answer. You can say something like selection by elimination. And after that, The possibility comes to B only. No other neighboring node is there because it's a directed graph like S to A to B, B to C. And you know the heuristic function value comes to 2 plus 6, it will become 8 actually. Okay, if you have any doubt, if you want to think about node C also, it will become 4 plus 2, 6, 6 plus 2, 8, 8 plus 6, 14 it becomes. So out of 14 and something what we have 8 is going to be the minimum cost. So the next node comes to B only. S, A, E, B, that is the order you are going for. S, A, E, and next comes to B. I think this is the only possible answer. If you want to check the remaining nodes with C, D also you can go for, but I think this is enough. You can confirm answer is B. Right? B is the correct answer to this question. The path comes to S to A to E, E to B, B to C, C to D and D to G like. My dear, this is one question we have taken in A star algorithm. In previous year gate also, we have almost one question like A star algorithm with goal path. So try to focus more on what do you call informed searches like A star. Okay. And after this discussion, we have some question that is what I mentioned about min-max algorithm, alpha beta pruning. They given two game trees like this, max value, min value in this way, max player and min player, and different options are available with for value of x and y. So what we are going to do is, we are doing alpha beta pruning here. If you want to do alpha beta pruning, what are the possible values that x going to be take? What are the possible values that y going to be take? That are available in the options, isn't it? I hope the question is clear to you. Now let me see. So when you are taking any game tree, the process of alpha beta pruning, it begins with something like this. So what we are going to assign, alpha is equals to minus infinite and beta is equals to plus infinite, isn't it? So what alpha is going to be take? Alpha is going to be take the maximum value in the along the total path. It's going to take maximum value. It points to the maximum value. That is the reason we are going to begin min-max algorithm with minus alpha minus infinite. So if we start with minus infinite, whatever may be the value comes to you, it's going to be maximum value, right? So, and one more thing is, in the game tree, there are some parent nodes and there are some child nodes. From the parent node, you can assign alpha beta values to the child nodes, right? But whereas coming to the reverse tracking of the algorithm, you cannot assign utility function values to the parent, right? From the child nodes, the utility function values will not go to the parent node. But from the parent node, you can assign alpha beta values in this to the child nodes. I hope that is the first point you should be clear of. And the second thing is, when you are doing alpha beta pruning process, whatever may be the values you are going to take, that values comes like from bottom to top, because the player starts from max min in that way. When you are taking that values, the process comes to beta should be less than or equals to alpha. I hope you remember that point. Whatever the nodes you have in the child places, if you update the value of something called min value, it's going to be affects your beta value. And if you update the value like a max player, it's going to be update your alpha value. And moreover, utility functions comes from bottom to top. And when you are taking the process, you can start the game tree. And moreover, you remember that it comes like a adversarial search, something like 2-person game. Okay. So I hope this condition is also clear to you. Let me mention that condition. Beta is less than or equals to alpha. Or you can say alpha is greater than or equals to beta. That is also okay with me. Now if you start here, the traversing of the graph comes in this way. And the Graham tree identifies that here there is a value 2 to the child node. So as you are taking the max player, so from 2 it can update the alpha value as from minus 2 to from minus infinite to plus 2. From minus infinite to plus 2, my dear. And after that, when you are taking this value something like beta, this beta comes to whatever may be the value here, what I required actually, I want x here. From this x, 2x, I want to take only max value. So indirectly what I am saying, when I want to say the max value, beta should be less than or equals to alpha. So the beta value comes to x here. This x must be less than or equals to your alpha in the sense 2. So if x is less than or equals to 2, you can take some value here. Let us suppose something like minus 1 or 0 or plus 1 or 2, you can imagine some value here. And coming to the min value, it going to be updated b value. So you can take anything, minus infinite, minus 5, minus 7, whatever you are going to take it. But next I am coming to the max player, that means 2 comma minus 1, 2 comma 0, something like that. It comes to 2 only. My dear, what I am saying is whatever may be the value of your x, it doesn't affect my final value of alpha, which indirectly means that there is no importance to this particular child x. That means I can simply prune this value x. That pruning process is nothing but elimination, right? And coming to the second game tree, here we have something like this. Let me start with alpha betas. Let me assign alpha is equals to minus infinite and beta is equals to plus infinite like this. And if I comes to b value, here it comes and here it comes to minimum. Actually 5 and y we have, we don't know what is the value of y, but I can say something like this. Here whatever I get is, it's something like minimum of 5 comma y. That minimum value affects your alpha value. Can I say in that way? Minus infinite become as minimum of 5 comma y. Yeah, depends on y value, the p value comes, from the p value, alpha value comes. So I don't have y value here, that's why let me make the point in a general way, minimum of 5 comma y. And after that, as I mentioned at the starting of the discussion, the alpha beta values are going to be shared to the chain node, and whereas coming to the utility function values of the chain nodes are not going to be shared to the parent node. You cannot assign that. That is not the rule in alpha beta pruning. My dear, here what I am saying is, at node E, alpha becomes minimum of 5 comma alpha, and whereas beta becomes plus infinite. So here you have some value. In this value, if beta is less than or equals to alpha, then we are going to do the process like pruning. In that scenario, what happens? Beta is less than or equals to alpha, in the sense my beta value is here, that is plus infinite. That should be less than or equals to minimum of 5 comma y. That beta value should be less than or equals to minimum of 5 comma y. My dear, when I can say that is minimum of 5 comma y, the ultimate result comes to 2 means, yeah, just to see, I already mentioned that x should be less than or equals to 2, then y should be minimum of 5 comma 2, in the sense the minimum value comes to 2 here if y is greater than 2, isn't it? So x value should be less than or equals to 2, in the sense 2, 1, 0, minus infinite, you can take any interval like this, and whereas y comes to 2 or 3 or y, any value you can take up to infinite. But coming to the minimum of 5 comma 2, in the sense I can simply take 2. My dear, in this scenario, option B is going to be correct. If you take x is minus infinite to 2 and y is 2 comma infinite, in that case you can happily prune that nodes like x and y, and I hope you are observing the brackets also very clear way. Here I have mentioned open intervals and closed intervals. You know the clear cut meanings of that. And it is a memory based question, so depends on the information, you can confirm that answer is B, my dear. This is one question what we got from alpha beta pruning. And as I mentioned that there is a question from propositional logic. In our pre-gate exam, what I expected is, last time they given the question from the question like ball, a ball in rugby game, some question they asked like. This time I expected he give a high level question like multiple quantifiers, but he touched a simple question like this, S1, S2, S3, S4. Yeah, my dear, see this formats, S1, S2, S3, S4. So which of the following can be true? So let me construct the truth table here. My dear, given values are like this, P here, Q. Let me take negation P also. In the first statement we have P implies Q, something like this. The both statements can be true, first one alone true, second one alone true, no one can be true like this. Coming to the negation P, and P implies Q, a true statement cannot returns the false statement. So you can take like TF, TT in this way. Yeah. Here I did S1, my dear, and let me try something called S2 here. Negation P and Q. Negation P and Q here. So if any one of them is false, it can be false. I think only in third area it can be true. Yeah, only third area it can be true. In remaining cases it can be false. I think it's like a almost quite opposite to this P implies Q. Yeah, somewhat you can say. And coming to third statement, negation P or Q. Negation P or Q here. Right. So negation P. Yeah, if P is false, yeah, negation P, let me see this area. If not P is false and also Q is false, if no one is true, in that case only disjunction becomes false, right? If at least one true, the result can be true. If no one is false, then only it can be false like. If no one is true, then only it can be false like. So if you observe this third column, P implies Q, and here not P or Q like this. So these two formulas are same in each and every possible situation. From the options you can understand, there are some options given here, just like S1, S2, S3, S4, 4 statements are there. Which of them can be equivalent, logically equivalent you can say. So S1 cannot be logically equivalent to S2, whereas S1 is logically equivalent to S3, my dear. Let me confirm like this. I am talking about this column and this column. Yeah, S1 is logically equivalent to S3. This is the actual meaning of logical equivalence. My dear, apart from this, the same question you can also solve within somewhat 10 seconds you can say. So if you take the first statement S1, that is P implies Q, I hope you remember the law called conditional law. Yes, we have a law like conditional law, or you can say implication law. Yeah, P implies Q can be write as negation P or Q. My dear, from that discussion also you can say something like this. The first formula S1 and the third formula S3 can be equivalent. In the class itself, we discussed implication law, by implication law, De Morgan's law, absorption law, and idempotent law, associative law, distributive law, law of absorption, law of dominance, law of identity, law of complements, involutory law, double negation law. Many laws we have discussed, and I mentioned many times, apart from the truth table, if you are okay with the properties, laws, we can solve the question in less time. This is one example to that. Yes, my dear? And also, I cannot say something like 100%, but I got some level information like in search techniques like this, my dear. They given a graph like this. They given a graph like this. My dear, what they mention is there is a graph, and in this undirected, unweighted graph, the shortest path between the two nodes like AD is, they confirmed like ABCD, and the shortest path between two nodes like E comma H is EFGH. Yeah, they clearly specified that, and they agree they are the shortest path. And they've raised a question like, which of the following cannot be the edge of this graph? Cannot be the edge of in the graph, in the sense some options are available, as we have some options like BD is one option, and we also have some option like EG, edge EG you can say, and we also have BG, BG or BH, something they given, and one option like BD, EG, and something like FH or something. My dear, what I am saying is, in the initial condition of the question, the examiner confirmed that the shortest path between A, B, C, D is, it's A to B, B to C, C to D, like that. So in that scenario, let us go some controversy. If BD is the shortest path, let me allow, if there is a edge between B to D, in that scenario, how it can ABCD become the shortest path? That is not possible, right? The shortest path between BD, indirectly I agreed that B to C, C to D like. And also something like EG, when I agree that EG is the path, if some edge available between E to G, then the shortest path from E to F, F to G, that is not going to be reliable. The statement is going to be false, I can say. And whereas when you are taking F to G, if F to G shortest path is available, the second statement, whatever the data you have given, EFGH, how it can be the shortest path? So the statement is going to be false. I think this edge is also not possible. Whereas coming to BH, BH what happens? In case of BH, कोई प्रॉब्लम नहीं, आपको कुछ नहीं फर्क पड़ता. BH in the sense, what you can say, let me say if there is a edge like B to H, my statements still they are safe. A, B, C, D, E, F, G, H, they are in safe side. The statements they are correct, I can say. So, which of the following in the sense, the reliable option is BH. My dear, what can I say is, some information what we got from the students and somewhat reliable sources, we discussed that. If there are some changes in the questions, the detailed solutions we are going to give later. I hope you understand that. And coming to AI questions, the questions what I can say is, the questions are not at all difficult. All the questions, whatever we discussed in the class, and moreover, according to our guess, whatever given in pre-gate exam, many times we discussed that alpha beta pruning and Bayesian networks, and these things are very, very important. But the unexpected thing what happened is, we discussed many things about time complexity, space complexity, about all uninformed searches, informed searches, all 12 algorithms, minimax algorithm, alpha beta pruning, they touched that. Okay, that area, leave it. But we discussed informed and uninformed searches. We guessed some question in that area, but that was not happen this time. Okay, anyway, I hope you did the exam in well, with your satisfaction. Yeah, students, wish you all good luck. Thank you.
Hello everyone, myself C.H. Srinivas, faculty at ACE Engineering Academy. At present I am handling subjects algorithm and data structures. So today I am going to take the opportunity to discuss GATE DA paper which was conducted in the morning session. Now I am ready to explain in detail solutions of algorithm and data structures questions. I have collected questions from the students where these are really reliable questions. They are not memory based questions, almost these are exact questions only. And my point of view, the standard of the paper is moderate to difficult. And most of the questions which are related to our class notes and pre-gate examination which we conducted in the month of January. You know, in pre-gate examination we ask questions from insertion sort, hashing and recursion concept. So clearly in this today paper also they ask question from insertion sort, hashing, recursion and all. Okay. So let me discuss some questions which I collected from the students. Okay. So first question based on hashing concept. The subject is data structures. They provide hash table of size 10. There is a hash table of size 10. There is a hash table of size 10. Just look at the question, how they asked. Consider a hash table of size 10 with the indexes starting from 0 ending with 9. So they clearly mention that there is a hash table of size 10. Our indexes are starting from 0 ending with 9. Let us draw hash table. So we can say let it be index and the key which you are going to store into the index. And index are starting from 0 and ended with 9. Therefore, hash table indexes are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? These are indexes they provided. Next, the hash function which they are going to apply to store the key values are h of x is equals to 3x mod 10. This is a hash function which they are going to apply to store the key values into the hash table. And what is the collision resolve technique to resolve the collision means they are using linear probing technique used to resolve the collision. Okay. The technique which they are using is linear probing technique. They are using linear probing technique to resolve the collisions. You know meaning of collision. If more than one key hash into the same location, then collision occurs. We can resolve the collisions with the different collision techniques like linear probing, quadratic probing, double hashing and separate chaining. But in this paper they asked question from linear probing. We did so many questions from the linear probing, friends. Okay. Then what are the key values they provided? And they provided key values are keys 1, 4, 5, 6, 14, 15. That's all. These are the key values they provided. And based on this information, they are asking question is the indexes where the key 14 and 15 are stored. They are asking to find indexes of the keys where 14 and 15 will be stored. Okay, we want to find that value. So let me store these key values by using hash function. So first if I consider key value is equals to 1, okay. So if x is equals to 1, we will take substitute x is equals to 1 here, that is h of 1 is equals to 3 into 1 mod 10. Obviously remainder is equals to 3 mod 10 means that equal 3, therefore it will hash into the third location or third index, okay, third location. So therefore 1 will be stored into third index. Clear, friends? Okay. Next, what about second key? Second key is 4. Therefore, if x is equals to 4, we can substitute 4 in the place of x. H of 4 equals to 3 into 4 mod 10. So 3 into 4 means 12 mod 10, that equals second index. Second index. So therefore 4 will be stored into second index of the hash table. Right, friends? Okay. Next one is 5. So if x is equals to 5, then h of 5 equals to 3 into 5 mod 10. So 3 into 5 means 15, 15 mod 10, that equals to 5. So it will stored into fifth index. So therefore 5 will be stored into fifth index. 5 will be stored into fifth index. Afterwards, next one, 6. If x is equals to 6, then h of 6 is equals to 3 into 6 mod 10. 3 into 6 mod 10. So in this case 18 mod 10, 18 mod 10 means it will go to 8th index. 18 mod 10 means remainder is equal to 8, therefore it will stored into 8th index. So 6 will be stored into 8th index. Right? Next, 14. If x is equals to 14, then h of 14 is equals to 3 into 14 mod 10. So 42 mod 10, that equal to second index. That equals second index. Now if you observe, second index already occupied by some key value, right? Hence collision occurs. In linear probing, whenever collision occurred at ith location, then we need to search into I plus 1th location. Therefore, if collision occurs at second location, then we have to search into third location. So therefore, after checking second location, check third location. But third location also we are having key value, right? Therefore, if again collision occurs, then search into next empty location. So how linear probing is working? If collision occurs at ith index, then searching process will start from I plus 1, I plus 2 till the last index, and then it is taking wraparound sequence starting from 0th index. So it means what I am trying to say, suppose if the hash table is 0, starting index is 0, 1, 2 and so on, I plus 1 up to so on m minus 1. Imagine m is a hash table size. Suppose if ith index collision occurs, then in linear probing technique, we have to search into next immediate empty location. So therefore, it is searching I plus 1th location. If I plus 1th location also collision occurs, then we have to search into I plus 2 location. That search process will continue up to m minus 1. Still, if you are unable to find an empty location, then apply wraparound sequence starting searching from 0th index like this, then followed by first index. This is a mechanism where we are using in linear probing technique. So here it is hashing to second index, but second index already having an element, that's why collision occurs. Then you have to search into third index, again collision occurs. Then where we have to place obviously next empty location. Therefore, 14 will be stored into fourth index. 14 will be stored into fourth index. And the next one, last key, that is 15. If x is equals to 15, then h of 15 is equals to 3 into 15 mod 10. So 45 mod 10, that equals 5th index. It is hashing to 5th index. Now check the hash table at 5th index location. But 5th index location already occupied by some other key element, hence collision occurs. Then apply linear probing and search next immediate location. Therefore, next immediate location is 6. Therefore, we can store the key 15 at 6th index. Therefore, in this problem, index of 14 and index of 15 they asked. Index of 14 and index of 15 they asked. So therefore, if it is a given data and if they ask what is index of 14 and index of 15, the options provided for this question is looking like this. See, first option 2 and 5 respectively. Second option 2 and 6 respectively. Third option 4 and 6 respectively. Fourth option 4 and 5 respectively. So these are options they provided. So they are asking question what is index of 14 and index of 15. So therefore index of 14 is equals to 4, index of 15 is equals to 6. Hence answer is 4, 6. That is option C is the correct answer. This question came from data structures. The topic is called hashing, friends. I hope most of you already did this problem very well because we already discussed so many questions based on this topic in the class. In fact, I discussed almost 10 questions based on linear probing topic. Okay. Let me discuss next question, friends. Okay. This is a data structures question and it is multiple select answer question, MSQ question. So they provided some theoretical statements with respect to binary search algorithm. Okay, just look at the question, the pattern how they asked the question. Which of the following which of the following input does binary search takes order of log n base 2 time. So this is a statement they provided, okay? And the options are looking like this. The first option, an array of n integers in the increasing order, okay? An array of n integers in the increasing order. An array of n integers in the increasing order. Means if the input array is in the increasing order and if it contains n elements, does binary search will take order of log n time or not? They are asking this question, okay? That is the first option they provided. And the second option, an array of an integer in any order. This statement is same, an array of n integers in any order. In any order. An array of n integers in any order. Next, option C. And third option, a linked list of n integers in the increasing order. A linked list of n integers in increasing order. In increasing order. Whereas in the fourth option, it is same statement, a linked list of n integers in any order. A linked list of an integer in any order. So these are the four statements they provided. Among these four statements, which statement will take time compressed order of log n base 2? In the class notes, we clearly discussed that in order to apply binary search algorithm, the pre-requirement is array must be in the increasing order, right? That is in sorted order, okay? So clearly if you observe first option, an array of n integers must be in the increasing order. If array in the increasing order, so let me take simple example so that you will get more clarity. Let us consider there is an array of n elements, like whose indexes are like 1, 2, 3, 4. So these are elements in the increasing order, let it be 10, 20, 40, 60, 80, 100, 120, 140. If the array elements in the increasing order, do you know how binary search algorithm is working? Binary search algorithm, first it is taking first index value as low index value and the last index value we are calling it as a high index value. By using low index and high index, it is computing mid index value. So there it is using formula is called mid is equals to floor of low plus high index by 2. Low plus high index by 2. So obviously low plus high means 1 plus 8, 9 by 2, that is 4.5. By applying floor, it will take 4. Okay. So therefore mid index is equals to 1 plus 8 by 2 that is equal to 9 by 2 4.5. When you apply floor, it will take fourth index. Now in binary search algorithm, it is comparing with the fourth index element first. Okay, so it is comparing the fourth index element. If the key is matching with this fourth index, it will return fourth index value. If it is not matching with the fourth index, then depends on the key value, either you have to search towards the left side or towards the right side. It means that half of the array will be neglected. Okay. For example, the key which you are going to search is something like x is equals to 120. Just imagine 120. So 120 is greater than 60. Therefore, we have to ignore left part of the array. We have to move towards the right part of the array. Therefore, the recurrence equation is looking like this. The time complexity for searching a key out of an element is T of n. The time complexity for searching out of an element is T of n. After performing comparison of the middlemost element, which is taking constant time comparison, let it be C, constant time comparison, then array will be divided into two equal parts, where your search will move towards either left part or right part. Suppose assume that in this case we are moving towards right part. In that case, how many elements are there in this part means clearly n by 2 elements are there at most. At most n by 2 elements are there. The time required for searching a key out of an element is T of n. The time required for searching key out of n by 2 element is T of n by 2. Okay. So clearly this array contains n by 2 elements. Therefore, it is taking T of n by 2 plus C. So T of n equal to T of n by 2 plus C. This is the recurrence equation of the binary search. Now we can apply master theorem, which we discussed in the classroom. Apply master theorem and solve this one. We will get time complexity for this one is equals to order of log n base 2. Clear? So therefore, option A statement is correct. Okay, option A statement is correct. Just look at here. The first statement is correct. An array of n integers in the increasing order, which is correct. So obviously option B is we can ignore because they mention any order. Ignore this one. Here option D also we can ignore here because they mention any order. So therefore ignore it. Now let me talk about a linked list of n integers in the increasing order. Suppose there is a linked list which contains n elements. All of them are the increasing order. Okay. Let me take simple example. You will get clear idea. I am creating a linked list with n elements which are in the increasing order. You know, linked list nodes get connected by means of pointers, links like this. Okay. Is a linked list of 5 nodes. Assume that elements in the increasing order, we are taking elements like, let it be 10. The starting node address, if I consider 100, next node address, let it be 200, 300, 400, and then 500. Okay. So first node is having address of the second node, therefore link field contain address is equals to 200. Right friends, okay. Where second node, let it be content is 20 and it is holding address of next node which is 300. Here it is 30, it contains address of next node that is 400. Let it be 40, 500. Next let it be 60 and here it is null. Because last node link field is pointing to null. Then how binary search is applicable on the linked list which is already in the increasing order? The first step is you need to traverse the list, complete list, in order to understand how many nodes are there. Okay, because in the array we are having indexes, but here there are no indexes, right? So therefore we have to take pointers. Okay, for example, if I take pointers, let it be n is a pointer pointing to this location, and also some other pointer I can take p is a pointer. Okay, then we need to traverse the list till you reach the last node. After reaching the last node, then we need to take first index and the last index values. Okay, then you can apply binary search algorithm, right? So in that case, traversing the list itself, it takes order of n time. order of n time. After supplying binary search, it will take maybe log n time. Therefore, the total time complexity is n plus log n, which is exceeding more than log n. Hence, this statement is also not correct. I hope you understood, right? Traverse in the list itself will take order of n time, but they are asking question with respect to order of log n. Okay, so therefore, this statement is also not correct. Okay, let us go back to the question once. So option C is wrong because traverse in the list itself it is taking order of n time. After supplying binary search will take again log n. So n plus log n, which is nothing but order of n. Okay. So therefore, option A is the correct answer. I hope you already answered this question because straightforward question which we already discussed in the class. Okay. This is second question from the data structures. Next. So I have collected one question from Python program. This is multiple choice question, MCQ. They provided two lists. Consider Python code declaration of two lists. Okay. So one list is having elements like A is equals to 1, 2, 3, and another list is having elements are 4, 5, 6. They provide two lists in the Python code. Then which of the following statement will result? Which of the following statement will result in A is equals to 1, 2, 3, 4, 5, 6. They provide options like first option A dot append of B, next one A dot update of B, A dot insert of B, and A dot extend of B. So these are four methods they provided. So which of the four methods will provide the result is A equal 1, 2, 3, 4, 5, 6. If you observe A initially already having 1, 2, 3, right? Okay, we want to extend A up to 4, 5, 6. So append method is always inserting element one element at a time. Okay, one element at a time. So therefore, this is not the correct way to insert elements like 4, 5, 6 here. Okay, and next A dot update B is updating the only element of A. Okay, it is not extending up to 4, 5, 6. Where A dot insert of B, it is inserting element at a particular index, whichever index we are providing, at that index we are inserting. Therefore, insert method also will not extend up to this one. Okay, whereas the extend method, it is taking number of elements occupied in B list. Okay, so how many elements are there in B list? 3 elements. Therefore, it will extend size of A. It will extend size of A up to next 3 locations, and those 3 locations will fill with the elements of B. Extend method will take input as a B list. It computes the number of elements in B. There are 3 elements are there. Then it will extend the size of A with 3 more locations, and those 3 locations will be filled with elements of B. Therefore, answer to this question is option D is the correct answer. Okay, this question came from Python code, friends. Okay. Next, one more question from the Python. We can also do this problem by using simple recursive approach. Let us define this program. They define a function with 2 parameters a comma b, and the conditions are looking like this. If a equals to 0, please excuse me. If a equals to 0, then return b. if A mod 2 equal to 1, then return 2 star of f of A minus 1 by 2 comma B. Otherwise return B plus f of A minus 1 comma B. At the end they provided the statement print f of 15 comma 10. This simple recursive program, friends. Okay, these kind of programs we covered so many questions in the class. Okay, so just observe what we are passing in the program. There is a function f which is passing two parameter values, that is 15 comma 10, where 15 will be copied into A and 10 will be copied into B. So let me call this function now. So the moment when you call the function f by passing arguments 15 comma 10, then two formal parameters will be created. One is called A, another one is called B, where A is holding value is equals to 10, 15, and B is holding value equals to 10. Now it will check the first if condition. If A equals to 0, obviously condition fail. So this condition fail, hence we cannot return B. If A mod 2 equals to 1, so right now A is equal to 15, so 15 mod 2, the remainder is equals to 1. Yes, it is correct. So the moment it is correct, this is a statement associated to this if condition. So therefore this statement will take place, rest of the statements will be ignored. Okay. So therefore if it is 2 star of f of A minus 1 by 2 comma B. Therefore first we need to take function called priority. It is taking 2 star of f of A minus 1 by 2. So right now A equal to 15. So 15 minus 1 14, 14 by 2 that equals 7. So 7 and B value is equals to 10. And at the end we have to use the statement is called return statement. This is the order of priority of execution of the statements. Okay. Now I am calling function with the input is 7 comma 10. It means that we are passing arguments from here 7 comma 10. The moment if you pass argument 7 comma 10, again two more formal parameters will be created now. A equal to 7 and B equals to 10. Now check the base condition. A equal to 0 condition false. Now A mod 2 equal to 1, yes. 7 mod 2 equals to 1, remainder is 1, true. Therefore again we need to call this function second time. That is 2 star f of A minus 1 by 2 comma B. So A value equals to 7, 7 minus 1 that equals 6, 6 by 2 that equal to 3. And B value is equals to 10. At the end we can use the return statement. Now if I call this function, again new formal parameters will be created, A equal to 3 and B equals to 10. After checking first base condition, where first base condition fail, then second base condition 3 mod 2 equal to 1, yes it is true. Therefore again you have to execute this statement now. Okay. That is 2 star of f of A minus 1 by 2. A right now 3, 3 minus 1 2, 2 by 2, right. So 2 by 2 that equals to 1. And B value is equals to 10. Afterwards you can execute return statement. Now when I call this function, A value is equals to 1 and B value is equals to 10. Again check the condition, A equal to 0, no. Then A mod 2 is equals to 1, yes, 1 mod 1, 1 mod 2 is equals to 1, true. Therefore again we need to call that function. 2 star of f of A minus 1, that is 1 minus 1, that is 0 by 2 that equals 0, comma 10. Afterwards you can return the value. So finally we are calling with the values like A value is equals to 0 and B value is equals to 10. Now check the condition, A equal to 0 or not, yes. Then what you have to do, return B value. So therefore last statement will return B value. Last statement it will return B value. What is the current value of B? That is 10. So it is giving back value is equals to 10. Now this 2 will be multiplied with 10. 2 into 10, that is 20. This return statement will return 20 to the previous level. Next again return 2 into 20, that is 40. This return statement will return 40 to previous level. Right? Next 2 into 40, that is 80. 80 will return to previous level. Then 2 into 80, that is 160. 160 will return to the calling place. From wherever we are calling to that location will return. So clearly in the program we are calling here. We are calling here. Therefore, the output for this program is equal to 160. So this is one of the beautiful program based on recursion. We already covered so many questions in the class. I hope you answered this question very well. Okay. And the next question based on insertion sort algorithm. The question is looking like this. Suppose that insertion sort is applied to the array where array contains elements like 1, 3, 5, 7, 9, 11, x, 15, 13. So these are elements they provide in the array. Now what did they ask the question? And it takes exactly 2 swaps to sort the array that's all. It takes exactly 2 swaps to sort the array. Then what did they ask the question? Select all possible values of x from the given. Select all possible values of x which satisfy this condition. Select all possible values of x which satisfy this condition. Okay, and they provide options like first option 14, second option 16, third option 12, and fourth option 10. It is MSQ question, multiple select question. So I hope every one of you are aware about how exactly insertion sort algorithm is working. I'll take simple example to explain insertion sort algorithm. Just look at here how the insertion sort algorithm is working, so that you'll get more clarity about. Generally, the object of insertion sort is, suppose if I consider an array index is, assume that it is starting from first index, second index, third index, and so on like this. Okay. Array index is starting from 1 instead of 0. The object of insertion sort is some part of the array is already sorted. For example, let us consider elements like 10, 20, 30. Now here if I take element is something like 6, and again 14, and then 7, let it be 16. The object of insertion sort is, if you observe, some part of the array already sorted. Clearly some part of the array already sorted. Now you have to pick up the key values from the unsorted part of the array. We want to insert that key into the sorted part of the array in the proper place. Okay. So the object of insertion sort is inserting a key element into sorted part of the array in its proper place. How insertion sort algorithm is working? Simply the element whichever we are going to place in the proper place, that element you can consider as a key element. So key is equals to 6. Okay, key is equal to 6. Whenever key is equal to 6, here insertion sort algorithm using one for loop where we need to start actually starting from the second index by assuming second element is not sorted. Okay, so suppose here if it already sorted, now we can take it as key element. Now trace the previous index element that equal 30. 30 is going to compare with 6. 30 is going to compare with 6. If 30 is greater than 6, then shift 30 to the next location. So clearly 30 is greater than 6, therefore shift 30 to the next location. Next location. But how do you trace this index means you can say I is the variable which is tracing this index. Now third index element is going to compare with the key element. 30 is greater than 6, yes. Therefore shift 30 to the next location. Afterwards decrement I by 1. I by 1. Now take second index element. 20 greater than 6, yes. Yes means you have to shift 20 to the next location and then decrement I by 1. Okay. Now take first index element 10. 10 greater than 6, yes. S means you have to shift 10 to the next location and then decrement I by 1. The moment I becomes 0, then you have to copy this key value into A of I plus 1 location. A of I plus 1 location means 0 plus 1 that equal first location. It means that if your insertion sort algorithm is looking like this, just observe how exactly it is working. Because this question is creating confusion about many students, that is the reason I want to discuss in detail this problem. So suppose you are writing insertion sort algorithm. An array where array contains n elements. Assume that array index is starting from 1. Array index is starting from 1 instead of 0. Okay. The first step, we are running one for loop for j is equals to 2 to a dot length. A dot length means number of elements in the array. Number of elements in the array, obviously n elements are there. Okay. Its meaning is up to first index array is already sorted. From second index onwards we want to sort. Because initially we don't know how many elements are sorted, therefore up to first index already sorted. From second index onwards we want to sort the array. Therefore the second step I am taking, key value is equals to A of j. Key value equal to A of j. Means second index element which I am going to place into the sorted part of the array. Okay. After previous index element we have to trace by taking I is equals to j minus 1. Right. Afterwards then we are applying while loop condition. As long as I greater than 0 and A of I value greater than key element, means if both the conditions are satisfied, if both these conditions are satisfied, I greater than 0 and A of I greater than key element, if both conditions are satisfied, then what you have to do, you have to shift A of I to the next location, A of I plus 1 location. We have to shift A of I to the A of I plus 1 location. Just observe the coding part. We are copying A of I into A of I plus 1 location. After copying, you have to decrease I by 1. I equal to I minus 1. Okay. This is the fifth step, it is sixth step. You have to continue this process as long as either of these conditions, both the conditions are satisfied. After some time maybe I greater than 0 condition fail. The moment I greater than 0 condition fail, then we need to copy key element into A of I plus 1. This is the way exactly how insertion sort algorithm is working by using Corman textbook algorithm point of view. Okay. According to this algorithm, we are shifting data movements are there. At the end we are copying key into A of I plus 1 location. That's why generally we are using data movements instead of using swapping word. Okay. Generally insertion sort algorithm we are using data movements, not swapping. But in this question they are asking about swapping. Maybe they are interchanging this word. Movements are replaced by swapping word. Okay, no problem. If you count how many movements are there, that is nothing but your how elements are shifting from one location to another location. That is important here. Okay. So how many elements are swapping? Let me take first one. Suppose if I take x is equal to 14, friends. Okay. Just if I keep it x is equal to 14. I am writing once again this array. Given array elements are like 1, 3, 5, 7, 9, 11, and then x, 15, and then 13. These are elements, okay. Please excuse me. This is insertion sort algorithm. So 11 and then x, 15 and then 13. Just look at this option. Suppose in the place of x, if I replace with 14, how many number of swappings are required? Just I am replacing x with 14. Now you can consider this is an array having indexes like first index, second index, third index, fourth index, fifth, sixth, seventh, eighth, 9. So clearly this part of the array is already sorted, right friends? Okay, this part of the array already sorted. Now I want to sort element from the 7th index onwards. Just observe, this part of the array is already sorted. I want to sort element from the 7th index onwards. So the moment if you want to sort from the 7th index onwards, your j value becomes, okay, j is starting from 7th index. Because here assumption is already sorted, so therefore j is starting from second index. Therefore your key is equals to a of j, okay. So just observe now. Suppose if I take x is replaced, if x is replaced by 14 now, I am replacing x is replaced by 14. Now in that case j is equals to, what is j? J is starting from 2 to a dot length I mentioned, by assuming that only one element is sorted. But here we are already aware that up to 6th index already sorted, therefore j must be 7th index, okay. So j is equal to 7th index. If j is equal to 7th index, what about key value? Key value is equal to 7th index element, that equals to 14. Right friends, key is equal to 14. And what about I value? I is equals to j minus 1, that is 6, 7 minus 1, that equal to 6. So we got parameters like key value and then I value, that equal to j minus 1. Now run this loop, I greater than 0, yes, 6 greater than 0 condition true. Then a of I greater than key or not, we have to check now. What is a of I? A of I means 6th element, right, 6th element. So 6th element is 11, it is checking the condition, 11 is greater than 14 or not, okay, it is checking the condition like this, 11 is greater than 14. A of I means that equal 11 and key value is equal 14, 11 greater than 14, condition false, condition false. So if the condition false, it will come out of the loop, copy key into a of I plus 1 location. What is key here? Key is equal to 14. A of I plus 1 location means 6 plus 1, that is 7th location. Therefore, a of I plus 1 means 6 plus 1, that equals 7th location, copy key value. What is key? Key is equal to 14. Right friends, okay. So we are copying 14 at this place only, Afterwards, next key is 15. So therefore, next pass, what we are going to do, next pass, just observe. Next pass, j becomes 8. When j is equal to 8, what about key value? Key is equals to 8th index element. 8th index element is 15. Then what about I? I is equals to j minus 1 according to algorithm. That is 8 minus 1, that equal to 7. Right friends, okay. Now take a of I, means apply this while loop condition. I greater than 0, yes. A of I greater than key. A of I means 7th index element. Now what is 7th index element friends? 14. So it will check the condition 14 greater than 15, condition false. 14 greater than 15, condition false. If the condition false, copy key into a of I plus 1 location. Simply copy key into a of I plus 1 location. That means a of I plus 1 means 7 plus 1, that equals to 8. What about key? Key is equal to 15. So therefore 15 again in the 15 place only. Means we are not performing any swapping so far. Now when key is equal to 13, okay, 13, in that case j equal to 7 already over, 8 over. Now we are going to take key is equal to 13. Therefore j value becomes 9. Remember, j equal to 9 means up to 8th index already sorted. Now 9th index element you need to place in the correct place. J equal to 9. What about key value now? Key value is equal to 13. In that case, what about I value? That is j minus 1, that is 9 minus 1, that equal to 8. Now check the condition, I greater than 0, 8 greater than 0, true. A of I greater than key. What is A of I friends here? 8th index element, that equal 15. 15 greater than 13, Yes, condition true. So the moment condition true, we have to shift this 15 to next location, that equal to 15. Afterwards, decrement I by 1, decrement I by 1, I becomes 7, I becomes 7. Now it is comparing 14 greater than key element or not. First I greater than 0, yes, then take 14, 14 greater than key element, 14 greater than 13, yes, true. True means copy a of I into a of I plus 1 location, means 14 is copied into 15th location, 15th location. After decrement I by 1, so decrement I by 1, I is equals to 6. When I equal to 6, check the condition I greater than 0, true. A of I means A of 6th element. What is A of 6th element? 11. 11 greater than key element. What is key element here? 13. Condition false. The moment condition false, you have to copy key into A of I plus 1 location. So A of I plus 1 location means A of I value right now 6. 6 plus 1, that equals 7th location equal to key. Key is equal to 13. It means that 13 will be copied into this location. Now in this case, how many swappings are there? Actually, we have to use the word is movements. But in the question paper, they ask swapping, right? That's the reason we need to adjust the question according to the given question paper pattern only. We cannot find the, we cannot say that question is wrong. Okay, actually, it's the data movements, but we can use a swapping word. These two words are interchangeable, okay? So one swapping, you know, so here between 14 and first one, 15 and 13, and afterwards 13 and 14. Total 2 swappings are there here, right? Okay? So initially 13 is here, 15 is here, 15 is shifted, one swapping. Next 13 is here and 14 is here. It is swapped here. Therefore, there are 2 swaps are there. When x is equal to 14, 2 swaps are there. Okay. So continue this algorithm like that. Okay. If you continue this algorithm, so x is equals to 14, 2 swaps are required. Apply if you take 16. In the easy process also we can do this problem, friends. Okay. You no need to do complete process because many people are getting ambiguity. That's why I explained complete algorithm. Otherwise, you can easily solve this problem. If you take 16, I got 3 swaps for 16. 3 swaps. Okay. You try by yourself. 3 swaps I got for 16. And next one, 12, we are having only 1 swap. We are having only 1 swap. Whereas if you take 10 again, if you take x is equal to 10, friends, x is equal to 10, 11 and 10 get interchanged. 11 and 10 get interchanged. Again, here 15 and 13 get interchanged. Again, 2 swappings are required. Therefore, x is equal to 10 also 2 swaps are required. Okay, 2 swaps are required. Actually, no need to use any coding part for answering this question, but many students are feeling ambiguity about this question. That's why I explained like this. Okay, it is easy question actually by substituting values. Therefore, answer this question is A, D. I hope most of you already did very well because all questions came from our class notes only. Okay. So still we have many questions are there. My colleagues are also going to discuss machine learning algorithm questions now. So one more announcement, like ACE Academy is offering coaching for online as well as offline. Please try to utilize this opportunity and we are here to support all of you. Okay, thank you for trusting us. Okay, now my colleague Uday Bhaskar sir is going to teach machine learning algorithm questions. Thanks for giving the opportunity, friends. Okay.
Hello. Now we will discuss the questions related to the machine learning algorithms part. Here there is a 1 mark question. A data set is given with the following data points: -1, 1, 2, -5, 3, 5 of the form x comma y. The given model for the data set is y is equal to mx using linear least squares regression. The optimal value of w is. This is a simple question. Basically, here we are having the data points. I'm having one feature x and its corresponding target y, and I'm having 3 data examples. They have been given as -1 for its corresponding target is 1, and 2, -5, and 3 and 5. So this is the simple data set that is given to us. Now the corresponding model is a simple linear regression model, that is y is equal to mx only. There is no c also. There is no intercept also. You have only y is equal to mx form. Then what is the, here this is w, y is equal to wx. So let us consider this as w or m, whatever it may be, that is basically it represents the slope or the weight in simple linear regression, and here the value of b is equal to 0. And in class we have discussed the ordinary least squares method, and in the ordinary least squares method, if you solve the expressions by making this b is equal to 0, then the corresponding expression for w would be simply given as the summation of x multiplied with y divided by summation of x square. In ordinary least squares method, if you have w and p both, then the mean values will also come, and that will be considered as the numerator will be given as the covariance between input and output, and the denominator will be given as the variance of the input. That would be the ordinary least squares output. But if you make b is equal to 0, then the related expression would be modified to this form, and the summation is to be taken over the number of data examples. Here the number of data examples are 3. So such that w optimum is equal to x multiplied with y for the first data example, that is -1 multiplied with 1 plus 2 multiplied with -5 plus 3 multiplied with 5 divided by, even in the denominator also you need to consider the square of the inputs for the 3 data examples. So that would be given as -1 square plus 2 square plus 3 square, such that it gives you the w optimum value is equal to -1 minus 10 plus 15. 15 minus 11 is 4 divided by 1 square is 1, 2 square is 4, 3 square is 9. So 9 plus 1, 10, and that will be 14. So this value is 2 divided by 7. So this will be the optimal value for the given w. Okay, so this is basically a simple question from the topic linear regression, simple linear regression. The topic name is simple linear regression. Next, C1 and C2 be two set of objects, and d of x comma y be a measure of dissimilarity between objects x and y. Two such measures are defined as follows. Dissimilarity 1 of C1 comma C2 is equal to maximum of d of x comma y, that is the distance, x belongs to C1 and y belongs to C2, and dissimilarity 2, C1 comma C2 is equal to minimum of the distance of x comma y, x belongs to C1 and y belongs to C2. This is a direct question, and which of the following statements are correct? And it is a multiple select type question. And single linkage clustering uses dissimilarity 1, complete linkage clustering uses dissimilarity 2, single linkage clustering uses dissimilarity 2, and complete linkage uses dissimilarity 1. Right, these are the given options, and it is a direct question based on the idea of a single linkage as well as the complete linkage clusterings. And if we have a data example, this is a cluster C1 and this is a cluster C2, C1 and C2, and you need to measure in single linkage clustering. Let us say here I am having certain data examples which are considered as x's, different possible x's, and here I am taking different possible y's. Then you need to measure the distances from this point to the 3 points here in this cluster C2. Similarly, from this point to this, you need to measure the distances. Among the calculated distances, this is one possible x, and here we have different possible y's. And that means always C1 belongs to x belongs to C1, and the data point y belongs to C2. This is what we have. Now, among these possible 6 distances, the minimum distance always is given by the single linkage clustering, and the maximum distance is given by the complete linkage clustering. Right? So, accordingly, this dissimilarity 1, dissimilarity is nothing but some proximity measure. That would be considered as some proximity measure, and so according to this, dissimilarity 1 deals with complete linkage clustering. So option D, as well as the single linkage clustering is with dissimilarity 2. So option C. So correct answer is C as well as D, both. Right, next question. A naive-Bayes classifier is used to solve a two-class classification problem with class labels y1 and y2. The prior probabilities are probability of y1 is equal to 1 by 3 and probability of y2 is equal to 2 by 3. And assuming a discrete feature space, the probability of x given y1, probability of x given y2, the values are given as 3 by 4 and 1 by 4. For a specific feature vector x, x is a specific feature vector or one data example. The probability of misclassifying x is, this is also a simple question from naive-Bayes algorithm. So let us discuss the idea. So the prior probabilities are given to us as well as the conditional probabilities are also provided to us. So the probabilities, the given probabilities are probability of y1, probability of y2. They are given to us. And probability of x given y1, probability of x given y1, probability of x given y2. These conditional probabilities are provided to us. Right, so those values are 1 by 3, 2 by 3, 1 by 3, and this is 2 by 3, 3 by 4 and 1 by 4, 3 by 4 and 1 by 4. So the objective or the idea is you need to, basically you need to obtain the misclassification probability is to be obtained, right? So that means if X belongs to class label 1, its belongingness to class label, if X belongs to Y1, its belongingness to Y2 would be misclassification. If X belongs to corresponding target is Y2, its corresponding class label is Y2. Suppose we don't know whether it is Y1 or Y2, that you need to predict or you need to obtain here. So what we need here is probability of Y1 for the given X as well as the probability of Y2 for this given X. These are called posterior probabilities. We need these probability values for the given X. If we are able to get these values, if among them which one is larger, that probability values corresponding class will be assigned. Its class label will be assigned to your X corresponding target, right? So in order to calculate this probability of Y1 given X, that is the posterior probabilities, we need to, what is the expression for probability of Y1 given X from our naive Bayes algorithm? The expression for posterior probabilities would be probability of X given Y1 multiplied with probability of Y1 divided by P of X. Similarly, probability of Y2 given X, that posterior probability would be probability of X given Y2 multiplied with probability of Y2 divided by probability of X. You need to obtain the probability of X here. You need to obtain probability of X. What is probability of X from our previous understanding, or we have seen this, so many problems we have solved. There is nothing but the product of probability of Y1 and probability of X Y1. That is, the probability of X is equal to probability of Y1 multiplied with probability of X given Y1 plus probability of Y2 multiplied with probability of X given Y2. So this is equals to 1 by 3 multiplied with 3 by 4 plus 2 by 3 multiplied with 1 by 4. So let us cancel out 3 here, 1 by 4 plus 1 by 6. So that's value is equal to, and taking the LCM as 12, you will get 5 by 12 as your probability of X. Now calculate the desired posterior probabilities. These are the desired posterior probabilities for us. Now everything is there with you. Probability of X given Y1 multiplied with probability of Y1. So that is there. So that value is 1 by 4. So we need probability of Y1 given X, that is equals to 1 by 3 multiplied with 3 by 4 divided by 5 by 12. So this value is equal to this value is equal to 1 by 4 multiplied with 12 by 5. So this value is 3 by 5. Similarly, obtain this posterior probability. That is probability of Y2 given X. Or else, because we are having only two class labels, probability of Y2 given X would be 1 minus probability of Y1 given X. That is also possible. Or else, you just see here, 3 by 4 multiplied with 1 by 4. That is 1 by 6. 1 by 6 divided by 5 by 12. So let me write here. The probability of Y2 given X is equal to probability of X given Y2, that is 1 by 4 multiplied with 2 by 3. 1 by 4 multiplied with 2 by 3 divided by probability of X, that we already calculated as 5 by 12. So this is equals to 1 by 6 multiplied with 12 by 5. So this value is 2 by 5. So now based on these posterior probabilities, what could be the class label of the given x? We know we always assign the maximum related, the maximum probability related. So among these two probabilities, we obtained this probability as 3 by 5 and we obtained this probability as 2 by 5. So that means, according to naive Bayes algorithm, what is the correct classification? What is the correct classification? If it is class label 1, then that would be the correct classification. But if it is saying that as class 2, then that would be the misclassification. So for the given x, the misclassification probability is given by this. So that would be 2 by 5. So the misclassification rate would be, the misclassification probability would be 2 by 5. Therefore, the correct answer is 2 by 5. Next question. This is a little bit lengthy question, but if you look at it in a step-by-step manner, if you break up the question into parts, and if you read the question thoroughly, here more or less, if you have some logical approach in solving the question, then this is a very simple question. It is like gradient descent algorithm. It is not exactly gradient descent, but there are some update rules are given to us. Some generic or generalized update rules are given to us, and based on these generalized update rules, we have to identify the correct answer. Okay, so it is not belonging to any specific algorithm, but it is more of a generalized approach related to regression ideas only. So a linear classifier is defined as y is equal to sine of f of x for given w comma b. And the function f of w comma b is weight vector transpose multiplied with x plus b on a data set d is equal to x1, y1, x2, y2, so on up to xn, yn, where xi, the feature vector, belongs to a d-dimensional space that is given as r power d, and I is equal to 1, 2, 3, so on up to n. We are having n different features. And also given that yi belongs to plus 1 or minus 1. Because it is a classification problem, we have only two possible classes. They are given as plus 1 and minus 1. So this belongs to, a simple idea here is, this belongs to the class label. It belongs to the class label. The class label could be either plus 1 or it could be minus 1. And the sine function, in the problem statement, it is given that what is the sine function? The sine function outputs a plus 1 if the argument is positive. That means if the corresponding value of this W transpose X plus B is a positive value, then this sine function results a plus 1. That is, it's positive and it outputs plus 1. Otherwise, if it is a negative value, if this function is a negative value, then it results or it outputs a minus 1. And what is this y is defining actually? It is giving a y hat to us. That is prediction. Okay, so this is the prediction and this is the class label. That is the ground truth. Okay, now some update rules are given to us, just like in your gradient descent algorithm. These are the update rules, similar to your gradient descent. The weights of the linear classifier are updated as W new is equal to W old plus Yn xn, and B new is equal to B old plus Yn. The update takes place when sine of your function, sine function, that is your prediction is not equals to the class label. Simple. The update. So this update takes place if and only if there is a mismatch between the predicted value and the class label, which makes sense, right? So for a given case of xn comma plus 1, so this is the defined case. For this given case, xn comma plus 1 and your function less than 0, that means it is giving a minus 1. Its corresponding y hat is a minus 1, right? And its corresponding y value is given to us, that is plus 1. So that means there is a mismatch associated with this data example that belongs to xn. So whenever there is a mismatch, then there will be an update, right? So in that update, we are getting a new weight and a new bias, W new and B new, according to these two rules. So now, what would be the possible condition? So your old values with the function is greater than new values, old value function is less than new values function, and both would be same, and yn multiplied with your function is equal to 1. So these are the given options, and actually it is a multiple choice question, right? So you just look at the option A, there is no there is no possibility for this expression, because your function is always given by the old value of W. It is defined by the W transpose. If it is a matrix, that matrix is to be taken if it is more than 2 or more than 2-dimensional feature space, or if it is just for explanation purpose, I will confine myself to only 1-dimensional space. Okay, so if it is a 2-dimensional, then it will be cumbersome. Okay, so even 2-dimensional is also cumbersome. That's why let us consider 1-dimensional and extend that to n-dimensional. That can be done. Many times we did in many problems while solving. This is one of the problem solving approach in machine learning. First, confine yourself to a single dimension or 2-dimensional data and extend it to n dimensions. Okay, right now, come back to this place where I'm having f of whatever the function that I'm getting here, that is the W multiplied with x plus b. So I have some value of W that has been multiplied with my given x plus the b value is also there. So that would be some value, some real number, and that would be multiplied with yn is always something greater than 1 or less than 1. There is no such rule, that there is no such possibility that there is equals to 1. So this is incorrect, right? Next, we need to figure out whether it could be greater than, less than, or equals to. Equals to is not an option because the rule is updating. Your rule is updating the weight and bias. Right, definitely. If your rule is W new is equal to W old, B new is equal to B old, then this is the possibility. Option D is the correct answer. But some other rule is there such that equality is not possible. So now either it could be greater than or less than. Okay, so for that I will consider a case where I am defining a case where my x value is equal to, I am taking only a single value of n. N is equal to capital N is equal to 1. Then the corresponding x is having only one value. That value I am taking as a 5, and W old I am taking some value 3. And because always the weight and bias would be initialized with some random or arbitrary values, that you know that, right? So W old is a 3 and B old is equal to 1. I am taking like this for explanation purpose. And then our F old is required. After that, you need to update, and we have to obtain F new. That F new is also to be calculated with the updated weight and bias, and whether which one is greater, that has to be checked. With one case, we can arrive to a conclusion. Or else you can take a negative value of x also if you have any doubt, and you can check. Okay, so my F volt is equal to the weight multiplied with x plus 1. So this value is 16. Right? And now W new. What is your W new? The old W plus your old W plus yn multiplied with xn. Yn, what is your yn that is given in the problem statement? Your yn is a plus 1 value for the given xn. Right? For the given xn, the actual given ground truth is plus 1. So, that would be yn multiplied with xn, so that 1 multiplied with xn. So, this is W new, and B new is equal to B old plus yn, that is B old plus 1. B old plus 1. Right? Just by what we are doing, the new updations are increasing the values such that definitely your F new function would be greater than for the same value of x, because in the problem statement, in the options, we are taking for the same value of x. If I would do F new is equal to the given x multiplied with updated W new. So what is your W new now? W new is equal to your W old plus xn. So that value is 8, and B new is equal to B old plus 1. That is 1 plus 1, 2. So your F new would be, so that your F new would be your x multiplied with W new plus B new. Obviously, this value is F new is greater than F old, or F old is lesser than F new, whatever it may be. And if you have any doubt, in place of x you can take some negative value also, and you can check that whether the new values are giving the obtained F new function is a larger value than the older value or not. That you can check, that I am leaving to you. But based on, by considering this case, by considering some random values, we can say that this condition is applicable for any possible values of xn, w and b, such that option C, where your f of xn with old values is lesser than f of xn with new values, is the correct answer. Right. Next question. This is a 2 marks question, a simple 2 marks question was asked related to the activation function. This is about the activation functions that we discussed in class. The activation function is a rectified linear unit. Which of the following statements are correct about a ReLU function where ReLU of x is equal to max of 0, x? Option A, ReLU is not differentiable at x equal to 0. ReLU of x is equal to ReLU of ax for all a belongs to R. And ReLU is continuous everywhere. And option D, ReLU is differentiable everywhere. Here basically a rectified linear unit ReLU is a function that can be shown graphically like this. This is my Z and it is f of Z. So this is your rectified linear unit ReLU, and it is defined as f of Z is equal to Z for Z greater than or equal to 0, and it is 0 for Z less than 0. So this is the mathematical expression for this function. Right. Now, this is a continuous function. The function is defined at each and every value of Z. Right, without any sudden hikes or jumps or any sudden steps or discontinuities. If your function is, the idea is continuous function idea is simple. You tell me one value of Z, I will give you its corresponding f of Z value. 0 is also a value. Right. So there is no ambiguity about the value of your function at any value of Z. For each and every value of Z, your f of Z is defined such that ReLU is a continuous function. ReLU is continuous. And what about the differentiability of the ReLU function? ReLU is differentiable everywhere except at x equal to 0. Because at 0, if you take the neighborhood, of 0, this is 0, and you take its right side, and you take its left side, the 0 plus and 0 minus values are not same. So the differentiable values of, if I am considering 0 plus and 0 minus in the vicinity of 0, at 0 plus I am getting some infinitesimally smaller value, a non-zero value, and before 0 I am getting some 0 value, such that if I am considering the difference, that is at both sides I am not getting the same value, that's why it is non-differentiable. It is not the case with, so the standard thing here is the ReLU is differentiable everywhere except at 0. 0 is the place where it is changing from, changing its behavior, right? So ReLU is not differentiable at x is equal to 0 such that it is differentiable everywhere will be an incorrect statement. Now, ReLU of x is equal to ReLU of ax. If you look at, if you apply this condition for z less than 0, then it satisfies that condition. But for z greater than 0, whatever the value, suppose at x is equal to 2, I am getting a value 2 in ReLU of x. Then ReLU of ax gives, at 2, it gives a value 2a. At 3, suppose it is giving a value 3, at ReLU of ax, it gives 3a, such that a totally different straight line will be formed with another slope. So, if this is ReLU of z, ReLU of az would be something like this. Your ReLU of az would be something like this, such that both are not same, and option B is also incorrect. Next question. It is a question from neural networks. This is also a simple question. A neural network is defined with the inputs U and V, weights A, B, C, D, E, and F, output Y. And the used activation function is R is equal to ReLU of X, and ReLU is defined, that is maximum of 0, x, we know that. The values are given as u is equal to 2, v is equal to 3 for these two values, and a equal to 1, b is equal to 1, c is equal to 1, d is equal to minus 1, and e is equal to 4 and f is equal to minus 1. Which of the following is correct? Dou y by dou a is equal to 1, dou y by dou f is equal to 0, dou y by dou a is equal to 1, dou y by dou f is equal to minus 1, dou y by dou a is equal to 8, dou y by dou f is equal to 0, and dou y by dou a is equal to 2, and dou y by dou f is equal to minus 1. A simple fully connected neural network is given to us with one hidden layer. Okay, and the corresponding values are given to us. The total corresponding weights as well as the input u corresponding value, v corresponding value. Totally, all the values are provided to us, and R here indicates the ReLU activation function. And you know, this is the input layer. This is the input layer, and usually we don't consider the input as a separate layer. We know that because there is no activation function, there is no used activation function is there. But this is the hidden layer, and this is the output layer, and everywhere we are using a ReLU activation function only. Okay, right now let me consider the structure. This is u and this is v, and this is the hidden layer neuron 1, and this is the hidden layer neuron 2. Let us identify this as h prime and this as h double prime. This h prime and h double prime are the corresponding outputs of this neuron. Let us take it. Let us consider it in that way. Okay. Now, u is connected to this one, and R here indicates the used activation function is ReLU. So u is connected to both, v is also connected to both, and then you have output layer where the activation function is again R, and this is connected with E, and this is connected with F, and this is A, this is a C, this is a B, and this is a D. Right? And now from the output layer we have the output Y. So this is the given neural network. Now let us consider the neural network with the corresponding values. U is a 2 and V is a 3. The value of u is a 2 and value of v is a 3, and all a, b, c, d, e, f values are also defined. A is 1, b is 1, c is 1, d is minus 1. A is 1, c is 1, b is 1, d is minus 1. And similarly, the values of E and F are also given. E is 4, F is minus 1. E is 4, F is minus 1. Now, what is the input to the first, the hidden layer first neuron? It is very simple. AU plus BV, right? So here from the first hidden layer, the first hidden layer is taking AU plus BV as the input. Now this input will be passed through the activation function, that is the ReLU activation function, and so obtain its corresponding value. AU, I need AU plus BV value. AU plus BV value is equals to 2 multiplied with 1 plus 3 multiplied with 1. So it is 5. So maximum among 5 and 0 is 5 only, such that my h prime is equals to 5 only. That I am considering as AU plus BV only. So my h prime is AU plus BV, that is equal to 5 only. And next, for the second neuron in that hidden layer, CU. So here it is CU plus DV is the input. CU plus DV is going there. So that is equals to CU 2 multiplied with 1 plus 3 multiplied with minus 1. So that value is minus 1. So now again, this CU plus DV is processed through the relay activation function, and the relay activation function will give you the maximum among 0, minus 1. What is that maximum value? The maximum among 0, minus 1 is 0, such that your h double prime is equal to, is giving, that is giving a CU plus DV, that is passing through the activation function, gives you a 0 value. Right? Now, so what is your y? Your y is equal to this h prime multiplied with e plus h double prime multiplied with f. Right? Again, this is also passed through the relay activation function. So that would be 5 multiplied with 4 is 20 plus this is 0. This entire thing is becomes 0 because 0 multiplied with f will be given to it. So what would be your output? Your output y is simply equals to AU plus BV multiplied with E. So this is the your obtained y. This would be your obtained y. Now, what is there in options and what you need to calculate? Dou y by dou A, dou y by dou f. Right? Now it is very simple. What is dou y by dou A? UE. So what is dou y by dou A? From this expression, dou y by dou A is equal to UE. And U and E, both the values are there with you. So U value is 2 and E value is 4, such that its value is equal to 8. Next, I need dou y by dou f also. Now, you just consider this expression, right? And if I am doing partial differentiation with respect to f, it gives h double prime. So what is that h double prime? H double prime is 0 value, right? So it gives a 0 value. H double prime is considered as the output obtained from the relay activation function. So that is 0, such that it gives a 0 value. So 8, 0 is there in option C. So option C will be the correct answer. Your correct answer is option C. Next question. A two-class problem defined in d-dimensional space with two class labels red and green. Mu green and mu red are the mean values for the two classes. A test set example is defined as x belongs to Rd. That is the d-dimensional space. The classifier calculates the squared Euclidean distance between x and means of the classes. That is given by this symbol. And the classifier is defined as follows. F of x is equal to mu red minus x square minus mu green minus x square. It assigns the label red to x if f of x is less than 0 and it is green otherwise. Which of the following statements are correct? F of x is equal to weight W transpose x plus b, where W and b are functions of mu red and mu green. And option B, f is a linear function of x. And option C, x is equal to 0 is assigned the label green if the Euclidean value of the norm of mu red is less than the norm value of mu green. And option D, f is the quadratic polynomial in x. Right. So this is also a lengthy question, but if the question length, if you have these kind of big questions, you need to divide the question into pieces and you have to identify what is given. You just need to read the question thoroughly 2 to 3 times and you have to identify what is given and what needs to be calculated. And most of the times the information that is given there will be related to some definitions and notations related explanation only. So if you filter out that, then you can recognize what is given and what is to be calculated. This question is a very simple question. But if you look at that by considering that Euclidean, squared Euclidean distance and all, and by considering this, you may think that this is a tough question. No, if you apply your logical reasoning, this is a very easy question. Okay, see, basically the mean values mu green and mu red are given to us as the mean values. And there is a test set example x, and whatever may be the feature space, let us confine ourselves to single dimensional space and we will solve the problem, and then that can be extended to any dimension. That is the approach. Okay, and what is the function that is given to us? That is important. The given function, the classifier function is f of x is equal to the squared Euclidean distance between mu red minus x, mu red minus x square minus mu green minus x square. So this is the given f of x for us, and if f of x is negative, then it assigns a red, otherwise if it is positive, it assigns a green to the class label. Again, it is a binary classification problem only. Here, in this year paper, algorithm is not mentioned. But in a more generalized way, most of the questions are related to binary classifiers. The generalized approach towards binary classifiers was asked, and we have covered them in some of the ideas we discussed in logistic regression, some of the ideas we discussed in naive Bayes, some of the ideas we discussed while studying clustering in naive Bayes algorithm, as well as decision trees. We discussed some of the ideas. So basically the approach to solve a question in a heuristic manner, we covered that in our course, right? So now this is given to us, and which of the following statements are correct? And again, it is a multiple select type question, MSQ type question only. And f of x is equal to W transpose x plus b. It is the possible form for the given f of x. Is it correct or not? That needs to be obtained. And W and b are functions of mu red and mu green. F is a linear function of x. Basically, a and b both are same. If f of x is equal to weight transpose x plus b, then f is a linear function, right? X is equal to 0 is assigned the label green if norm of mu red is less than the norm of mu green, and f is quadratic polynomial in x. Just by looking at this expression, you may think that this is f of x is a quadratic polynomial in x, right? But if you do some mathematical manipulations based on this, what is the classifier is what is this function is calculating? It is calculating the squared Euclidean distance. It is calculating the squared Euclidean distance between x and the mean values, right? This is one squared Euclidean distance, this is another squared Euclidean distance, and their difference is given, right? Now, what is the Euclidean distance expression? The standard expression for Euclidean distance would be, if I am having only one x and one y values, then it would be simply square root of x minus y whole square. But it is a squared Euclidean distance, so square and square root will be cancelled, and it gives x minus y whole square, right? So here x is given, in place of y you have the mean value mu red, such that now on applying the squared, on considering the squared Euclidean distances, squared Euclidean distance measure, this would be simply equals to, your f of x would now be simply equals to mu red minus x whole square minus mu green minus x whole square. That's all. This is the only step that you have to take here. Automatically it gives you the answer. A very simple idea, correct? So this is equals to, now mu red square plus x square minus 2 times mu red multiplied with x minus mu green square. I am taking minus to the whole function, minus 2 times mu green x plus x square. Now I am simplifying it, x square and the minus x square, they will be cancelled with each other, and this would be further simplified as 2 times mu green minus mu red. 2 times mu green multiplied with mu red multiplied with x plus mu red square minus mu green square, right? Right, now you just see, this is my W. If you want, you can, if it is in vector form, that will be W transpose, and this is my B. So is it linear function or not? You just look at the function. Now this is W. If it is multiple linear regression kind of thing, it will be a common practice to consider weight W transpose and B. B is a vector and W transpose as a vector, and it is a common practice. If it is simple linear regression kind of thing, then simply you have W multiplied with x plus B, right? So whatever it may be, in a more generalized manner, it is a linear function. And again, depending on the number of features that you have in feature values that you have in x, the weights will be defined, right? So in that manner, this would be a linear function. right? So if it is simple linear regression, it is Wx plus B. If it is multiple linear regression with 2 or more than 2 features, it is W transpose X plus B. Whatever it may be, it is a linear function only, right? Such that option A and option B both are correct. And x is equal to 0 is assigned the label green. If x is equal to 0, then the corresponding assigned label would be if mu red is less than mu green, the assigned label is green. Let us put x equal to 0 in this expression. Let us put x is equal to 0 in this expression. Your f of x is equal to, simply if I am putting x equal to 0 here, if I am putting x is equal to 0 here, then my f of x would be mu red square minus mu green square. Right? Among red and green, which one is larger? In the statement it is given. Among red and green, red is small. Red is small. So red is small. So f of x is a negative value. Because red is small, in the problem statement, it is given that red is a smaller value and green is larger value. The f of function, f of x would be a negative value. Your f of x would be a negative value. Correct? Such that, now if it is a negative value, in the problem statement, it is clearly given, mentioned that it assigns the label red if f of x is less than 0. If it is a negative value, the assigned label is red. But if x is equal to 0, assigned label is green, will be an incorrect statement. F of x is not a quadratic polynomial because x squares have been cancelled out on doing some mathematical manipulations, such that option D is also incorrect. Right? So the correct answer is A and B. The correct answers A and B. See, just only one step is giving you the answer. So if you read the question carefully and properly, then this is not a tough question. Right, next question. A linear binary classifier is given as f of x is equal to sine of W transpose x plus B. The data set is given as class 1, 2, 0, 0, 2, 2, 2, and class 2 is 0, 0. A hard margin SVM is solved to obtain W and B values. Which of the following statements are correct? Option A, W is equal to 4, 4 and B is equal to 1. And option B, support vectors are 3. Option C, training accuracy is 98%. And option D, the margin is √2. And what is a hard margin SVM? In class we have studied, we have gone through a detailed hard margin SVM analysis and soft margin SVM analysis. First we studied hard margin SVM. If there is a clear separability is possible, if a clear separability is possible between one class to another class, then that is hard margin SVM. So if we are able to separate the two classes with a line or a plane or a cube or with a hyperplane, then that would be a hard margin SVM. And on what kind of data we are able to do that? On the training data. So on the training data, if you are able to do that, then what would be the training accuracy? It is always 100%. So a hard margin SVM always gives 100% training accuracy, such that option C is not correct. Okay, and how many support vectors we have here from the given data set? So let us identify them on the feature space. So let us consider your x1, that is your first feature, and x2, That is your second feature. First feature associated values 2, 0, 2. Second feature associated values are 0, 2, 2. That belongs to class 1. Class 1, I am identifying it with plus 1. And class 2, I am identifying it with minus 1. Because f of x is identified as sin of w transpose x plus b. It is mentioned there. Right? So, now, identify first of all, class 2 is 0, 0. So, this is that point that belongs to class 2, and I am identifying it with minus 1. And class 1 related data examples are 2, 0. So, this is 0 and 1, and this is 2. And here also, this is 1 and this is 2. Next, 2, 0, this is one data example that belongs to class 1. 0, 2, 0, 2, this is another, and 2, 2. So, this is one more. So, these are the 3 data examples that belongs to plus 1. That belongs to class plus 1. Now, from the feature space, whatever I have represented in a 2-dimensional manner, we are able to identify, or we can identify the support vectors. Right? You know the idea of support vectors, then this is the margin line, and this is the margin line. So, now, how many support vectors we have? On drawing this, we have 1, 2, 3 support vectors. Right, support vectors are 3 would be a correct statement. Now, what about the given w equal to 4, 4 and b is equal to 1? Are they really the w and b values? And in support vector machines, we have studied a simple expression that is given as each and every data example has to satisfy the condition, that is yi multiplied with w transpose xi plus b would always be greater than or equal to 0. Whatever may be your class, this is the condition that needs to be satisfied. Right? Now, w is given as 4, 4. So, consider data example by data example. This is your first data example, x1, 2, 0. You consider w transpose, that is 4, 4 is to be multiplied with 2, 0 plus the given b value is 1. And this has to be multiplied with its corresponding yi. What is its corresponding yi? That is plus 1. So, that is equals to 8 plus 0 plus 1. 9 plus 1, that is 9. So, its value is greater than 0. Like that, if you consider 0, 2, 4, 4, 0, 2 plus 1 will also gives you the same value. 2, 2, 2, 2, 4, 4, 2, 2 plus 1. That value is 17 multiplied with plus 1. That is also giving a value greater than or equal to 0. And now, if I am considering the class 2, 4, 4, 4, 4 multiplied with 0, 0 plus b, that is plus 1, is to be multiplied with its corresponding class label, class that is minus 1. So, then it is equal to a minus 1. Right? that is equals to a minus 1 such that this condition has not been satisfied. This is for all I values. For all I values, we know all the data examples that are there in your training set must satisfy this condition. If this condition is not satisfied, then that will be not your W and B corresponding values. Those are not your weights and coefficients that are given by your training method, by your in your hard SVM, in your hard margin SVM, such that this is incorrect. Now coming to the margin calculation. Now the expression for this line is x1 plus x2 is equal to 2, and the expression for this line is x1 plus x2 is equal to 0. What would be the marginal line that would be the mean or the midpoint between these two? We know that always the decision boundary would be taken. The decision boundary would always be taken like this only. That has the midpoint. So what would be the expression for this decision boundary? Your decision boundary for the given support vectors. For the given support vectors, the decision boundary is simply given as x1 plus x2 is equal to 1. So that would be your decision boundary. x1 corresponding coefficient is its weight W1 is equal to 1. x2 corresponding coefficient W2, that is 1. So 1 comma 1 is the weight vector. Okay, and in deciding the margin, what is your B value that is not required? What is the expression for margin from our study? Margin is equal to 2 divided by norm of W. Right? So that would be 2 divided by square root of 1 plus 1, that is equal to root 2. So this value is equal to root 2. So root 2 would be the margin. Right? So the margin is root 2 is correct statement. So options B and D are correct. So as a whole, the machine learning questions are not specific to the algorithm, but it is more in a generalized manner, and that we have covered at some extent at some place in some algorithms. So if you have been gone through them thoroughly, then the paper is very easy. Especially my subject, machine learning, is easy to moderate, we can say. Okay, thank you very much.